Okay, hi everybody. I hate to interrupt good conversation because it's good to hear conversation of a bunch of people who've shown up in person this morning. So thank you so much for being here. I'm very excited to have the Climate Symposium this year. We have a fantastic panel, which I think you'll really enjoy. I want to point out that this is technically, this is Tony, and I don't know if Marjorie's here at the time. Tony, nope, just Tony, started the Climate Symposium in 2006. So we are getting close to 20 years of convening together to talk about scholarship related to climate change. So I want to welcome you to whatever this would be after 2006, 18? Yeah, whatever. So, and I think we continue to grow. We have 200 people who are supposed to show up in person today. Of course, some of those folks won't make it at the last minute, and then we have a certain number of people online. And we have folks here from, just in terms of our community who's showing up, from, of course, the greater New York area, but also all the way in the Mid-Atlantic down to Maryland. So we represent a chance for our scholarly community to get together, students, staff, faculty, talk about climate change, spend some time talking to each other. We grow every year, and we're a regional force. At least I hope we're getting there. I think we are. So thanks, Tony, for kicking us off in 2006, and thank you all for showing up today and participating, and I hope you have a good time. So the first thing I want to do is bring up the Vice Provost of Research, Denise Hien, and she will kick us off today. And as she's making her way up, I'm going to sing her praises a bit because she helped us, from the Chancellor's Office perspective, negotiate everything that we had to do to combine the three sort of legacy institutes into the Rutgers Climate Energy Institute. So she's been a tireless advocate for us, and in particular helping me negotiate all the crazy politics of Rutgers. So thank you so much, Denise.
Thank you, Julie, and good morning. Good morning. I feel like we have to appreciate these kinds of mornings with the sun shining as it is and the cool, crisp temperatures, despite the fact that we're in drought, obviously. But particularly in these times, I really appreciate when the weather is good, and also all of you, because you guys are the ones who are going to help us save the planet. So I'm delighted to be here to welcome everyone to the Rutgers New Brunswick Douglas campus. And on behalf of our Chancellor, Francine Conway, who regretfully was not able to join us here, I'd like to acknowledge what an honor it is to join so many faculty, staff, students, and invited speakers as we celebrate this wonderful symposium today. And as Julie said, I'm Denise Hien. I'm the Senior Vice Provost for Research. And I also like to introduce myself as a social scientist who I do trauma and addiction work in my, as a side hustle. But I also see myself as a citizen of the planet, as we all are, and that probably should be the first identity that we all speak to. And it's not, it's not something novel for you guys, because you do this work, but I think that as a human being and person in the planet, that we all have to care about the issues that you guys have been working on for so many decades now. And so, as you know, working across disciplines to address some of the world's greatest challenges is a hallmark of Rutgers New Brunswick, which of course makes us a world-class powerhouse for research, and it's one of the reasons that we have, for a second year in a row, been named the number 15 top public universities in the nation. So we're very excited about that. And over the past several years, Chancellor Conway has been implementing our academic master plan centered on 4 pillars of excellence, one of which is innovative research. And we have been implementing that pillar with the Rutgers Climate and Energy Institute, which we launched just a year ago as the first of a series of interdisciplinary scholarly communities across multiple academic units here at Rutgers Rutgers, New Brunswick. And so I like to say that RCEI is the line leader for our chancellor's signature research initiatives. The other ones focus on artificial intelligence and data science, the Life Sciences Alliance, and we have a new one coming on, which is behavioral health and equity. So these 4 initiatives comprise the sort of portfolio of what, at the chancellor level, we're saying are our signature areas that we want to help to support, sort of Rutgers, New Brunswick-wide, Rutgers-wide, so, crossing all campuses, as well as statewide, and then, of course, in our nation. And I think Julie has gotten it off to a great start with all of the people who have been part of the task force. And so Rutgers RCEI has made significant strides in the first year as a unifying home, connecting faculty, staff, and students through climate change and energy research, innovation, education, and outreach that strengthens our position in developing knowledge needed for a resilient, equitable, and sustainable climate future. And under Julie's leadership, we've brought together more than 200 faculty and staff affiliates across 4 thematic areas of the Institute, which, for those of you who don't already know, are the Earth Systems Science is one area, renewable energy, technology, and conservation, human dimensions of climate migration, adaptation, and resilience, and climate change communication and environmental humanities. So this past year, her team launched the Institute's Convergence Research Program to bring together scholars to solve the most vexing research problems and to foster deep integration across disciplines. And this program, coupled with the Institute's Groundworks grants that fund capacity building to catalyze development of comprehensive transdisciplinary projects around a common theme, have already set a model for our other signature initiatives to follow. In its inaugural year, RCEI awarded groundwork grants to faculty affiliates Chuck Dismukes of the Waxman Institute of Microbiology and the Department of Chemistry, Yelin Lee of the Department of Civil and Environmental Engineering, Mary Whalen of the Department of Environmental Sciences, and Qixing Zhu of the Department of Mechanical and Aerospace Engineering, just as an example of the diversity of folks that got funded to lay the foundation for competitive research proposals and scholarship towards emerging global emphasis on the bioeconomy in addressing climate change. And for those of you who don't know, bioeconomy, like myself, bioeconomy harnesses the power of biology and novel production of goods, services, and energy to grow the economy and workforce while improving quality of life and the environment. The Institute is also the home to development of the Center of Sustainable Governance in the Anthropocene, known as CSAGA, because we always have great acronyms, don't we? Under the leadership of Professors Pamela McAuley and Rachel Schwamm from the Department of Human Ecology. And this signature initiative is exploring the policy innovations needed to address the interdependence of ecological and socioeconomic systems, spatially and temporally distant and diffuse environmental impacts, novel conditions of deep uncertainty about many emerging problems, and the potential for irreversible tipping points, cascades, and feedbacks in the Earth system. CSAGA has 3 case studies under development through multidisciplinary working groups in fisheries and marine governance in the face of rapid environmental change, safeguarding island food systems, and equity-driven nature-based solutions to biodiversity loss. And a public symposium on sustainability governance in the Anthropocene was held in May. In August, the first ever summer school in sustainability governance was held at Rutgers, where 29 early stage researchers from 20 institutions across the US, Canada, Brazil, the Netherlands, and the UK came together to learn about governance issues, strengthen research capacities across a range of skills, and build a cohort of like-minded scholars. And this is just the first of, this type of cross-cutting initiative that RCEI has started to support. As the State University of New Jersey, we are also committed to research that is of prime importance to the state. So housed within the Institute is the Wind Energy Test, or WET, Center, under the leadership of Professors Oner Bilgin of Mechanical and Aerospace Engineering and Josh Kohut of the Marine and Coastal Sciences. The WET project is focused on validation of predictive models for floating offshore wind turbines, including the design for a testing center to be located in New Jersey near the shore, and as well as similar test facilities on the Rutgers New Brunswick campus itself. So many of you have participated in the North American Wind Energy Lo-TEK 2024 conference that was hosted here just 2 weeks ago, which brought together engineers and natural and social scientists from around the world. And it was a really fun event. So it lasted over about a week, and there were all kinds of graduate student events as well, bringing in graduate students as well as scientists from all over the world, partnering with industry. So in the coming months, we'll be integrating the Offshore Wind Energy Collaborative, our community of faculty and researchers working in offshore wind within the umbrella of the Rutgers Climate and Energy Institute. The Institute has also supported professional development for our faculty, graduate students, and postdocs, and in the past year alone, it provided a skill-building workshop to improve designing climate change and energy research to meet broader societal impacts. Its student support program provided critical travel assistance to almost 30 graduate students to further their education, scholarship, and collaborations for fieldwork, scholarly conferences, special workshops, and field courses. And the Institute also continues to support and develop programs with faculty across the university who provide critical expertise in professional development for K through 12 New Jersey educators in helping meet New Jersey's first in the nation student learning standards that incorporate climate change across all subject bands. That's amazing. Thank you. There's so many ways that RCEI has already, and Rutgers has already taken steps in helping to lead not only, within our local community, but really the nation on, these cutting edge climate specific topics. So that recognition that climate change affects all sectors of society and that every subject band, even in K through 12 education, has a touch point to climate change is really at the heart of what we do at Rutgers in terms of bridging our research education across subjects and sectors for addressing these wicked problems. As Julie mentioned, we've been holding these climate symposia since 2006 here at Rutgers, and in the last decade expanded them to include faculty, staff, and students from throughout the region because we want to continue to build bridges with our colleagues in the region. So welcome to all of you who've come today from Maryland to New York. You are from community colleges, universities, federal and state agencies, public and private, and minority-serving institutions, and many of you are participating online. We couldn't be more honored to have you, and we hope that today's symposium provides you with knowledge, new opportunities, and rewarding collaborations, and those fun kinds of collisions that happens at symposia like these. So I hope you have a wonderful day, and welcome to all of you. Thank you.
Thank you, Denise. So I want to take a minute and do a couple shout outs. In particular, I wanted to alert you, I guess, to our next Convergence event or funding opportunities. And this will be a chance for us to collaborate with the new Rutgers Artificial Intelligence and Data Science group called RAD, which I like. And we're going to focus this year on the intersection between artificial intelligence and climate change, which is a two-way street there. So we hope to we will be announcing those opportunities for more convergence grants associated with that, and a big event associated with that, which will bring those of you who are interested in the intersection together in one place. That includes, I want to make sure that everyone understands, that includes climate change and renewable energy. So that's one thing to get on your radar, and if you haven't gotten enough emails from Oliver or myself, then you'll get a few more related to this initiative, which is what we have decided that's our next step after we have today. I also want to acknowledge the late Frank Sposato, and he was an economics major, 1973, I think it was, but he's been a strong supporter of climate change research, and in particular this symposium. So a gift that he and his family made enable us to have this event in part, and we very much appreciate those contributions. If anybody else out there would like to add their lot in with the Sposato family, we really welcome that. It's always a challenge putting these things on in terms of what happens in the bank account, if you will, or our funding mechanisms, and I don't think that's going to change anytime soon. So we really appreciate if you find that you appreciate these sort of events in any way, to think about us. I also need to thank our planning group. We have a fantastic group that are sort of function as my area leads, which include Dunbar, Burnie, Tony Broccoli, Kevon, Rhiney, and Atif, Akin. So those are our area leads across the 4 areas. They're a great group. I don't ever dread area meetings, you know what I mean? It's like there's some meetings you don't like. That's not one of them. We have a very good time together. We think very well together. We dream very well together, so I very much appreciate their support over the years and in getting this together. Also included in the group that helped plan this was our former area leads in a couple areas, including Rachel Schwam and Jackie. So thank you, Jackie Thaw. So thank you so much for all their help in getting this all together. So this year, we always have to think about what our theme is going to be. And this year, we decided it would be climate communication, which we then branded in one of our meetings where we dream up things as just signals. What signals are we getting? What signals are we getting both from the climate itself, and what signals are we sending out as a scholarly group in terms of how we're communicating what's happening with climate change? So for those of us who've been thinking about it for a while, it's very frustrating, right? Because we know what's happening. There's not a lot of mystery to what's happening. Even when I teach a class on climate change ecology, some of the first lectures I give are, what is the greenhouse effect and why are we changing it? Like, it's not that hard to figure out what's happening, right? Physics doesn't lie. But it is difficult to sort of take that knowledge, because it can be very heavy knowledge, to be honest, and think about what that means moving out. So if we are to respond effectively to what we're seeing and not lose hope, then we need to talk to each other, and we need to talk not just the people in this room. So that was part of the goal today. So I've invited several people to talk today who I think excel in that area of speaking out, not just to each other, but to the rest of the world. So I'm very pleased to have you guys here. They flew in, and there's one zooming in, and I just can't thank you guys enough for taking the time and come do this. So with that, we're going to move into this. The way we work, if you haven't done this before, is we have each of our plenary talkers come up, and talkers. They do talk, but I should call them speakers, presenters. So they'll come up and and talk to us about their research or their scholarship. We'll hold questions until the end. I'll call the panelists back up. We have comfy chairs up here. And then we'll do a moderated sort of session. I'll kick us off with a few questions, and then we'll open it up to the floor. And also remember, and I'll remind you later, that we prioritize students in terms of asking questions. So if you're a student who has a question, remember, you get to go first. Even though you might be a little nervous, you get to go first and ask those questions, because we like to hear what you want to say before we hear what some of the other folks have to say, right? So that's how we run things, and so let's go ahead and get started, and then I'm going to invite Tony Broccoli up to introduce our first plenary speaker.
Thank you, Julie. I want to start out with a little bit of history. The first papers connecting carbon dioxide to the temperature of the Earth were written during the 19th century. But at that time, there was no way of knowing whether or not this theoretical connection between carbon dioxide and climate that was based on the laws of physics was actually affecting the temperature of the Earth. Part of the reason was that we didn't have good long-term climate records at that time. It's taken a while to build up those long-term records. But another issue relates very directly to the theme of today's event. When we're trying to see the human effects on climate, we're looking for a signal, but the climate system is very noisy. There are things going on that affect temperatures around the world that are independent of climate change. So the trick is to try to pick out the signal that we're looking for from that background noise in the climate system. It's my pleasure today to introduce someone whose work was instrumental in identifying that signal of the human effects on climate. In 1995, in the report of the Intergovernmental Panel on Climate Change, that report contained the following statement, which I'm going to read to make sure I get it right because it was a carefully crafted statement. The balance of evidence suggests a discernible human influence on global climate. Ben Santer has dedicated his career to trying to find the signals of the human impacts on the climate system that rise above the noise of our background climate variability. He worked for many years at the Lawrence Livermore National Laboratory, Department of Energy Laboratory, in a group that looked carefully at climate model simulations and observations to try to, first of all, make sure the models were behaving realistically, but also to help see whether or not the models and observations were telling us a reasonable story. He has been recognized in many, many ways. I could spend too much of his time telling you about all his accolades, but I will mention that he's been a MacArthur Fellow. He's a member of the National Academy of Sciences. And just this past February in Baltimore, he received the Carl Gustav Rossby Medal, which is the highest honor of the American Meteorological Society. So it's my pleasure today to introduce my colleague and my friend, Ben Santer.
Good morning. Thank you, Tony, for that very kind introduction. So my life, my scientific life, has been spent fingerprinting the climate system, trying to disentangle human and natural effects on climate. But I'm not just a climate scientist. I'm also a rock climber, and one of the joys of being an old dude is that I get to go with my son, who now has all of the leading responsibility, and try and follow him up stuff. This was taken about a month ago at beautiful Tuolumne Meadows, the high country above Yosemite. If you ever get the chance, go there. I'm a US citizen, but I actually grew up in Germany and was educated in the UK. And as Tony mentioned, my career intersected with the Intergovernmental Panel on Climate Change, or IPCC, in the early 1990s. This was an organization that was set up by the World Meteorological Organization and the United Nations Environment Program in 1988. The goal of the IPCC was and remains to inform the governments of the world about the physical science of climate change, about the likely impacts of human-caused fossil fuel burning and other activities on our planet's climate, and about possible mitigation and adaptation strategies. The first report in 1990 essentially concluded that the jury was out in terms of whether humans were or were not affecting climate. For those of you who can't read it, I'll just read out that first sentence. The unequivocal detection of the enhanced greenhouse effect from observations is not likely for a decade or more. Enhanced means, as Tony mentioned, that there's a natural greenhouse effect, and by burning fossil fuels and putting more heat-trapping greenhouse gases in the atmosphere, we're enhancing that natural greenhouse effect. Fortunately or unfortunately, whichever way you look at it, I was asked to be the convening lead author of the Climate Change Detection and Attribution chapter in the 1995 second IPCC report. I don't need to look at that sentence. It's engraved in my memory, those 12 words, and they will follow me to the end of my days. After 1.5 years of work involving dozens of climate scientists around the world, we reached this 12-word finding: the balance of evidence suggests a discernible human influence on global climate. Back then, that was one of the first times that the international scientific community spoke with one voice and said, formally, we can identify a human-caused global warming signal. That was controversial back then. I spent roughly 2 years of my career explaining the scientific underpinning for that finding, defending that finding, and the process by which it had been reached. There were calls for my dismissal with prejudice from my position at Lawrence Livermore National Lab. It was rumored that I was going to be indicted by the Hague International Court of Justice for, quote, falsification of internationally relevant scientific documents, unquote. It was a bad time. There was nothing in my scientific career as a relatively young climate scientist that had prepared me for being in the public arena. We're trained as scientists to defend what we've learned, the appropriateness of our research methods in an arena with our peers, but not to defend our integrity and account for why we're working on climate change issues. It was a very, very valuable learning experience, and I'll talk a little bit at the end about some of the communication lessons that I learned from those 2 years. Extraordinary claims demand extraordinary proof, and the subsequent IPCC assessments in 2001, the third assessment report, in 2007, the fourth assessment report, came to much more definitive conclusions than our cautious, even wimpy balance of evidence suggests. Importantly, they tried to quantify the size of the human effect on climate. Look at those words up there, I'll read them. In the fourth assessment report in 2007, most of the observed increase in globally average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. And the words in yellow have a specific probabilistic meaning. They're calibrated likelihood language. The 2013 report used extremely likely, so we're more than 95% confident that the statement is correct. And the most recent IPCC assessment, the sixth in 2021, used this word here. It is unequivocal, I'll read it, that human influence has warmed the atmosphere, ocean, and land. So this is the arc, if you will, of climate science history. How did we get here? How did we get from the jury is out to unequivocal? I'm going to spend a few minutes trying to explain how I think we got from the jury is out to unequivocal human effects on climate. One reason, as Tony mentioned, is that computer models of the climate system have evolved in important ways over time. Back in the late 1980s and early 90s, we had the first models of the atmosphere that we were trying to couple to the ocean. Primitive models of sea ice, but not really models of the land surface, of atmospheric chemistry. And over time, modeling groups around the world began to develop these much more complex Earth system models. The most recent 6th IPCC report that I mentioned evaluated roughly 100 climate models from institutions and countries around the world. We have a better understanding of the factors, both human and natural, that influence climate. Back in the late 1980s, much of the focus of research was on fossil fuel burning and on human-caused changes in greenhouse gases. But it was recognized that humans do other things. We modify the surface of the land by deforestation. Particulate pollutants like sulfate aerosols and soot aerosols can locally and even regionally affect the climate. The sun is a variable star. Its energy output changes on timescales of 11 years and longer. That's a natural effect on climate that we need to understand. Massive volcanic eruptions, Rutgers has one of the world leaders in studying that, Alan Robach. They too can influence climate, sometimes for years at a time or longer. And there was recognition that we need to study all of these things in order to understand how and why climate is changing, not just human-caused changes in greenhouse gases. Back in 1995, at the time of the discernible human influence finding, we had 17 years of satellite measurements of global scale changes in atmospheric temperature. Now we have 45 years. That longer record has enabled us to better disentangle human and natural effects on climate. Think of that. In the late 1970s, we transitioned to a global understanding of changes in our planet's temperature, not just at the Earth's surface, but throughout the full vertical structure. We began to understand changes in moisture and rainfall patterns, again, transcending local and regional understanding to truly global pictures of how our planet's climate was changing. That was important. Tony mentioned the group that I was involved with at Livermore, the so-called Program for Climate Model Diagnosis and Intercomparison. So unfortunately, not as nice an acronym as the ones, RAD. Much PCMDI doesn't roll off the tongue like RAD. We should have consulted you before we came up with the acronyms. Our job was to evaluate the entire world collection of climate models to perform benchmarking, if you will, simulations that everyone would perform, including the group that Tony was at, the Geophysical Fluid Dynamics Lab in Princeton, and then make the simulation output available to the entire world scientific community. If you will, crowdsourcing of the evaluation of climate models. That was huge too, because it meant that many, many thousands of eyeballs were looking at climate model simulation output, comparing them with satellite data and other observations, and learning about errors in the models, possible causes of those errors. It was huge, that opening up of the diagnosis of climate models. And we developed infrastructure, things like the Earth System Grid Federation, for efficiently moving around petabytes of data so that you can now, from the comfort of your own office, interrogate literally petabytes of simulations from all the world's climate models. That was huge too in terms of advancing that arc of history. And finally, and this is what I'm going to spend the rest of the time talking about, we had this consilience between basic theory that Tony mentioned, how greenhouse gases trap heat and change the temperature of the atmosphere. We had the satellite data, we had the climate models, and we had pattern recognition methods that enabled us to compare simulations with observations and make inferences about causation. I love this word. E.O. Wilson has a book, I believe, called Consilience. So Webster's defines this as the principle that evidence from independent, unrelated sources can converge on strong conclusions. So as Tony mentioned, we had long-standing theory about the impacts of carbon dioxide changes on climate. We had data, and in the 70s, satellite global measurements of atmospheric temperature change, computer models of the climate system, and pattern recognition methods. How did the climate science community put all of this stuff together? Well, this man, whom many of you in the room know, Suki Manabe, was very, very influential in doing these early simulations like this. So back in 1967, in a very famous paper, which has been referred to as one of the most famous papers in climate science, Suki and his colleague Dick Weatherald at the Geophysical Fluid Dynamics Lab took a very simple climate model that just resolved global mean changes in temperature at different layers of the atmosphere, and they increased atmospheric CO2 from 150 to 300 to 600 parts per million. And when they did that, they found that the stratosphere cooled and the troposphere, the lower atmosphere, warmed, and that cooling of the upper atmosphere got larger the higher up you got above Earth's surface. So basically, with the addition, human-caused addition of greenhouse gases to the atmosphere, we're more effectively trapping heat low down and the upper atmosphere is cooling. And this really was a true prediction because this is 1967. We don't have the satellite data to probe high up in the atmosphere to determine whether Suki Manabe was right or not. Now we do. These are satellite measurements from a variety of different satellites. And what we're doing here is looking at a slice through the Earth's atmosphere from the South Pole to the North Pole and from close to the surface right to 50 kilometers above it. And what you see here is that this pattern is very similar to what Suki Manabe and Dick Weatherald showed. Warming of the lower atmosphere, with largest warming of the Arctic, where we've seen this very large, roughly 50% decrease in the extent of Arctic sea ice, cooling in the upper atmosphere, and as Manabe and Weatherald predicted, this cooling is getting larger the higher up you get into the atmosphere. Enter this gentleman. He looks a little bit like Kenny Rogers. He was my postdoc supervisor at the Max Planck Institute for Meteorology in Hamburg, Klaus Hasselmann. And together with Suki Manabe, he won part of the 2021 Nobel Prize in Physics. Why did Hasselmann win part of that Nobel Prize? It was for the introduction of fingerprint methods. Hasselmann recognized that one could borrow from electrical engineers in climate science. Electrical engineers knew how to identify coherent signals embedded in noisy data. And as Tony mentioned, that's the same in the climate problem. We've got natural climate variability associated with El Niños and La Niñas and a whole zoo of internal oscillations of the climate system. We're trying to recognize human signals against that background noise. Hasselmann provided strategies for doing that. And his key insight was that up to the late 1970s, most people who were doing signal-to-noise analysis looked at individual grid points. See that grid on the surface of the Earth? They were doing signal-to-noise analysis, trying to identify human-caused warming signals at individual locations. Hasselmann said it's much more efficient if you take a step back and look at the entire pattern rather than one individual location. So I'm going to give you an example of what fingerprinting actually looks like. And the first thing I'm going to show you is a sequence of slices through the Earth's atmosphere. Again, from the surface right up to 50 kilometers above it. This is satellite data, and I'm going to march through starting in 1986, near the beginning of the record that goes right up into the upper stratosphere. and show you a sequence of these observations. And you can see that over time, what's happening here is that as Manabe and Weatherall predicted back in 1967, the Earth is showing this fingerprint of warming low down and cooling up high. And when you compare the observations with a modeled prediction of how atmospheric temperature should have changed in response to human-caused greenhouse gas changes, you can generate some measure of similarity between the human influence fingerprint predicted by a model and the actual satellite data. And this time series here shows you what you can see with your eye, that over time, the model predicted fingerprint is becoming increasingly evident in the observations. And what you really want to know is this increase over time significant? So we have counterfactuals, we have model simulations with no human influence on climate, and you can run them for many, many thousands of years, which we routinely do, and you look at the chance correspondence that you might expect. This is the correspondence we actually got between the satellite data and the fingerprint over the 37 years of the satellite record. This is what you might expect just due to chance, just due to random noise in the climate system, El Niños, La Niñas on 37-year timescales. It's virtually impossible to get the observed result by chance alone. Physicists use 5 sigma as their gold standard for the discovery of particles like the Higgs boson, the so-called God particle. In climate science, in terms of the vertical structure of atmospheric temperature change, we are way, way, way beyond 5 sigma. There's no way that natural causes, volcanoes, the sun, internal climate variability, can give us what we've actually measured and monitored. Well, why? Look at the left. So the left, again, is, as Manabe and Weatherall predicted, this pattern of warming low down, cooling up high. In the middle and on the right, you see estimates of the natural variability of the climate system. They show differences between the tropics and the extratropics. They show features that climate scientists know and love, things like the Brewer-Dobson circulation. They're small scale, they're noisy, they know nothing like what we are doing to atmospheric temperature. And all models, and these are now not the radiative convective models of Manabe and Weatherall, 1967, these are full Earth system models 55 years later. All of them, when you increase greenhouse gases, show this unique fingerprint of warming low down, cooling up high. Fingerprints of the sun and volcanoes, again, looking in slices through the atmosphere, look nothing like the human influence fingerprint. So back in 1995, at the time of the balance of evidence suggests finding, one valid criticism of that was, well, you folks are only looking at temperature and only looking at the Earth's surface. Go look through the atmosphere, go look through the ocean. Climate scientists responded to that justifiable criticism by going way beyond temperature-only fingerprinting studies. We looked at atmospheric circulation, we looked at rainfall, we looked at water vapor in the atmosphere, we looked at salinity, at runoff from major river basins and how that was changing as the hydrological cycle was changing. We looked at Arctic sea ice. Here too at Rutgers, one of the world's experts in looking at snow, David Robinson, was able to show that the changes in snow cover as a function of time were highly unusual. So the consilience, if you will, is that all of these different attributes of the climate system are independently monitored by thousands of scientists around the world, and yet they all tell a common story, that natural causes can't explain the patterns of climate change we've seen. Just to show you, this is work that I've been involved with colleagues here and elsewhere. that went beyond surface temperature to look at atmospheric temperature, the height of the tropopause, the transition between the lower atmosphere and the stratosphere, the amount of water vapor in the atmosphere, the heat content of the ocean, snowpack depth in mountains of the western United States, runoff from major snow-fed river basins, cloud properties, ocean temperature changes in hurricane formation regions, so-called hurricane breeding grounds, the march of the seasons themselves, the seasonal cycle of troposphere temperature or of ocean surface temperature, and increasingly the properties of drought. So we've moved way beyond looking at temperature only. Importantly, attribution also enables you to quantify the contributions of different factors to observed changes. And this is from the 6th IPCC assessment. And what it shows here is that our best estimate of the contributions to warming over 2010 to 2019 relative to 1850 to 1900 from human-caused fossil fuel burning, that red bar there shows you that estimated contribution of roughly 1.5 degrees Celsius with some error bars because we're looking at different models, we're using different attribution methods, but that's our best shot. Other human factors like sulfate pollution cause a net cooling, and that's the best estimate of that. The total human influence, if you add the warming and the cooling, is that bar on the left. And these are our estimates of the natural contributions to the observed warming over the last 120 plus years. Solar and volcanic is small, internal variability is small. So that's where we are. And I'm going to end with a little thought experiment. It's something I'm doing now that I'm kind of excited about. And I hope, since the theme of this symposium is communication, that this is a useful tool for communicating to the public. So what if we had satellites in 1860? And those satellites enabled us to measure, with the same accuracy we can today, atmospheric temperature, from the surface right up to 50 kilometers above it. Now, humans are just beginning to burn fossil fuels and ramp up heat-trapping greenhouse gases in the atmosphere. How long would it have taken us, with that capability back in 1860, to identify human effects on climate? And in simulation world, we have these simulations that go back to 1850 or 1860. They're part of the most recent 6th IPCC assessment. You can perform this Gedankenexperiment and look at those simulations and answer this question. So that's why I got up at 5 o'clock this morning to try and finish this paper. And here you see for 6 levels of the atmosphere. So at the top, we're going into the upper stratosphere, roughly 45 to 50 kilometers above the surface. This is lower down in the stratosphere. This is the lowermost stratosphere that's been profoundly affected by ozone depletion. And here's the troposphere, the upper troposphere, the lower troposphere. So the bottom line here is the black is the model simulations from 9 different state-of-the-art models. In model world, when we ramp up CO2, we warm the troposphere and cool the stratosphere, like Manabi and Weatherall predicted. That cooling gets larger the higher up you go in the atmosphere. These little wiggles here, that's the sun. That's the 11-year solar cycle that has a larger effect higher up in the atmosphere. These green lines here, these are massive volcanic eruptions. This is the eruption of Krakatau in 1883, which warmed the stratosphere and cooled the troposphere. The bottom line is that in the stratosphere, where the signal of human-caused cooling of the upper atmosphere is large and the noise is relatively low, we could have identified with high confidence a human effect on climate by no later than about 1887. So we could have known 135 years ago that what we were doing to Earth's climate was not natural. you can perform a second thought experiment and ask, would that have mattered? Would that foreknowledge have mattered or changed how we decided to, and how much fossil fuels we decided to burn? I'm not the guy to perform that thought experiment. Many of you in the room here are, but the point is that we can no longer claim ignorance or innocence. We know and could have known for 135 years that we're performing a grand geophysical experiment with Earth's climate, and the likely outcomes involve serious, serious harm for many billions of people around the world if we don't bend the curve and reduce emissions. I'm going to end here, but end by showing you some pictures. These are pictures I've taken over my lifetime as a climber in the Alps, in the Himalayas, in the Rockies, and most recently in the Juneau ice field in Alaska. And they're to illustrate that over one human lifetime, I've witnessed profound changes in these high altitude environments around the world. The glacier, the first glacier that I ever stood on with my dad in Austria in 1996 is almost gone. In addition to the scientific imperative to understand the reality and seriousness of human effects on climate, there's also an important moral and ethical discussion to be had. I'm not just a climate scientist. What does it mean to me and to you if we lose these beautiful, fragile places, if we lose rainforests and coral reefs? We need to have a discussion not just about likelihood of human effects on climate and whether to characterize those as extreme or very likely, but also about what these profound changes mean to us as human beings. Thank you very much.
I'll let Oliver do his thing. But yeah, if you guys are in the back and you want to move up, then this is a good time to make that happen. It feels a little bit like I'm teaching in a classroom where no one wants to sit in the front row. But come on up. So I want to ask Dunbar Burnie, who is our area lead in renewable energy and energy conservation, to introduce our next speaker. Are we ready? We good?
So it's my pleasure to introduce Katherine Blunt, who will speak to us about California burning, the fall of Pacific Gas and Electric, and what it means for America's power grid. I'm especially pleased to be making this introduction because here I serve as the area lead for renewable energy and sort of tech, but interdisciplinary kinds of connections that help solve problems for society. And I see and I sit in a material science and engineering department, and which is a very interdisciplinary kind of field. But I see it in the failures in the grid that we've seen in California and other places. I see some really strong connection to materials problems. What about corrosion of steel that's part of our infrastructure? What about thermal effects on photovoltaics? The efficiency goes down as the temperature goes up. And so I feel like what we're going to hear is going to lead to discussions that will bridge different fields and maybe help us find better solutions, policy and economics and fundamental science. So Katherine is a reporter for the Wall Street Journal and has published this book, California Burning, and was a finalist for the 2020 Pulitzer Prize. And so let me introduce Katherine. Please welcome.
Good morning. Thank you for that very kind introduction. I agree there's a lot of interesting connections to be made in this room, I hope. We're going to talk today about PG&E. Let's see if I can get this going here. How do I get this on the, oh, there we go, great. So for those who are not familiar, PG&E is the largest utility company in California. It's one of the largest in the country. And you know, the title that I came up for with this talk, when climate change came for PG&E, it kind of makes it sound like it was like a surprise. And I think for many within the company it was, but as Ben really well articulated in his presentation, there was many opportunities for this company to understand what climate change meant. And there was many opportunities that the company could have acted differently to try to assess the risk of climate change and what it meant for the consequence of infrastructure failure, which is really very much a key theme of this conversation today. So the most consequential moment for PG&E in recent history was November 8th, 2018, when a hook on a century-old transmission tower broke nearly in half and dropped a live wire early in the morning during very windy conditions, sparking what became known as the Camp Fire. The fire spread, by some estimates, the equivalent of 80 football fields a minute, destroyed the town of Paradise and nearby communities, and killed 84 people. And it was just, I mean, this sort of failure is, in some ways is remarkable in its simplicity, right? When you look at this right here on the screen is a photo of the hook that broke. It was original infrastructure hung in roughly 1915, thereabouts, and had been hanging on this tower, sort of rocking back and forth during windy conditions over the course of 100 years until the hook finally gave way. But so simple as that is, the sort of reasons why the company failed to not only assess this specific risk, but also, again, the consequence of infrastructure failure as tens of millions of trees died throughout Northern California over the last 10 years. We're going to get into that. And so I'm going to talk a little bit about the history of the company. I'm not going to spend too much time on it so that we can really focus on the climate aspects, but some of the history is really important in understanding how we got here. So PG&E, the sort of monopoly utility that it is, like many other utilities in the United States, only really had one real competitor. It was a company called Great Western Power, and it was actually Great Western that built this sort of sprawling transmission system in the Sierra foothills in Northern California near Chico. And the two companies merged in 1930, creating the monopoly that we know today. But what's interesting about that is that when this merger happened, PG&E inherited this infrastructure that it had no role in building, and sort of the records of it and the information about how the system was built sort of got like lost or sort of purged with time. And that's a very common issue for utility companies. I mean, they've been around for a really long time, and records maintenance is consistently a challenge. So we'll return to this, but again, that's sort of when the hook broke and that tower failed, ultimately leading to what became the Camp Fire, PG&E had very, very little information on that infrastructure. Now this is a really complicated moment in time that I'm going to try to condense the best I can. But fast forward to roughly 1998, 1999, there's a conversation playing out across the United States about how to bring electricity prices down. And there was an effort to so-called sort of deregulate the electricity space, which in my view is very much a misnomer. Electricities and utilities are always going to be regulated. But there was this idea to allow for the generation of power to be competitive. So to essentially hive off that function for the utilities, give it to the competitive markets, allow for there to be price competition. Ultimately, the hope was to reduce the cost of wholesale power. And California was one of the first states to really experiment with this in earnest. It created a competitive wholesale power market. There was the structure of it, just to put it simply, made it vulnerable to manipulation. Enron was a key player here. And what ultimately happened was the cost of wholesale electricity went through the roof. Utility companies were not able to charge customers for the cost of that power. They incurred a lot of debt. PG&E sought bankruptcy protection for the first time, first of 2 times in the last 20 so years. So the company has to go through this very complicated restructuring process in the early 2000s. And so that's significant in the sense that when it emerged, the company became very intent on regaining the trust of its shareholders, became very intent on improving its financial performance. And it's a good moment to pause and think about how utilities make money. So they earn a set rate of return, regulated, on investments that improve the overall value of the system, like building a new transmission line or, sort of any iteration of that, upgrading a substation. They do not make money on day-to-day operations and maintenance costs, so inspecting a power line or inspecting a gas pipeline or making a tiny repair, something that's not like kind of easily quantifiable as to what value it adds. That's just a pass-through cost. So some of the best financial performers in the industry are in the utility industry are very adept at cutting those operations and maintenance costs and sort of free up money to invest as capital. And there was an effort coming out of bankruptcy, what was called business transformation, sort of a way of saying we are really trying to improve our financial performance. PG&E cut too close to the bone on operations and maintenance costs. And this would have very significant, not only was this, I sort of laugh at this, this was, this utility reporter was, it's the union newsletter. And a lot of these initiatives to try to improve efficiency failed. So this was it was a time of like really bad morale within the company, and just like all the cost cutting didn't really do what it thought it was going to do. So it's not like it was like a success in some ways and a failure in others. It was just a failure across the board. So yeah, this was like, it's like very of the time, right? Some consultants came up with this, like the vision to be the leading utility in the United States, delighted customers, energized employees, and rewarded shareholders. I think the only thing that was achieved there was rewarded shareholders for at least a brief period of time. So now we get into the climate aspect of all of this. And so one of the most important moments, I think, in assessing what has happened in California is the witch fire in San Diego in 2007. It was ignited by a power line owned by San Diego Gas and Electric. 2 people were killed, 45 firefighters were injured. And it sort of did enough to make the California Public Utilities Commission, which regulates the utilities in California, think about whether it needed to do more to push all of the large utilities in the state to address fire risk. So I apologize in advance that, I know some of these regulatory filings are a little kind of like they're wordy, but they're important, I think. So like this was proceeding opened in 2008, about a year after the fire. It's in order to consider revising and clarifying the commission's regulations designed to protect the public from potential hazards, including fires. As the devastating fires in Southern California during the last 2 years have shown, there may be potential problems associated with electrical utilities and communication infrastructure providers' facilities, right? Which may necessitate additional commission safeguards. This is very straightforward. And so as with any sort of regulatory proceeding, this kicks off, there's a lot of a lot of attorneys kind of activate, and it turns into a really lengthy proceeding. And so let's keep in mind, this is 2008 when the PUC is asking this question. And this is a satellite image of California in 2008 in terms of, there's like many areas of the state, it was more than 1,500 fires burning throughout the state in 2008 as the PUC is asking this question. There's some in Southern California, there's a lot in Northern California. Arnold Schwarzenegger was governor at the time. He sort of famously said, we don't have the resources for this. Who has the resources for 1,500 fires? Like, something is clearly happening, something is changing, and something needs to be done to address what is becoming a pretty critical question about changing climate. And So it took the PUC a while to make this, this map here that's on the left, showing where some of the highest threat fire areas are. But I mean, look at that. There's sort of the parallel is pretty stunning. Taking a quick break in the conversation about fire to comment on a very significant issue that PG&E had to deal with around this time. One of its gas transmission pipelines exploded in San Bruno, which is just south of San Francisco. It killed 8 people and it destroyed a neighborhood. And it was just devastating. It took more than an hour to stop the flow of gas. I mean, a news helicopter circling the area. I mean, it looked like a flamethrower, right? It looked like this mushroom cloud of fire. That is the pipeline itself. It ejected out of the ground. I mean, it's just almost like comical in the way that it was just like, I mean. So all this is to say that when this pipeline exploded, PG&E, in a sort of reactive way, brought in a lot of people to try to understand what had gone wrong within the gas division. Part of it was, really the crux of it was that the company over the last number of years had reduced the thoroughness and the frequency of its inspections. Again, sort of talking about the overall effort to reduce O&M costs. And so they did a pretty thorough top to bottom risk assessment to try to figure out exactly what had gone wrong, what risks remained, what needed to be done to address them. And the individual who led the effort was an East Coaster. He's from Boston, and he had suggested to colleagues in the electrical division that maybe they should undertake a similar risk assessment, right? Just to know, just to try to determine, you know, where the risks were. Were their inspection processes thorough? Were they doing enough to maintain the infrastructure on that side of things? And they said, we're fine. Everything we've been doing is fine. We haven't had any really major disasters. So returning to the PUC proceeding, this idea that that regulators should do more to push the utilities to address fire risk. So this, like I said, it goes on for many years, and ultimately, PG&E in 2011 says, we do not agree that it is necessary to file a formal plan specific to fire prevention. And then further, just to sort of, I guess, bolster this argument, they say, Southern California is most susceptible to fire risk. We are not. And so again, I mean, we've already seen the 2008 map, right? Northern California was on fire. And around this time, I should be very clear that California had seen some very significant periods of drought. So now trees were dying for 2 reasons: lack of water and also an invasion of bark beetles, which are sort of invasive pests that are able to sort of, when trees are stressed and they don't have adequate nutrients, they're very susceptible to this bark beetle that just sort of finishes the job. And what's interesting, so you can see 2011, as PG&E is making this argument, there's a reprieve in the drought that had been happening for a number of years, but it's going to get worse and then much worse. Also, as PG&E's attorneys are making this argument as it relates to fire risk being most acute in Southern California, a different set of attorneys is doing a different analysis for the company. And you can see here that they are becoming increasingly aware of the fact that their equipment is starting fires. Right here we have, I mean, this was at one time a confidential document showing ignitions 2007 to 2010. Most of them are occurring when vegetation comes into contact with the equipment. And when you think about the consequence of drought for a company like PG&E, if a power line falls in a forest and the trees are largely healthy, the chance of that fire spreading to become catastrophic are lower. But as thousands and then millions of trees die, the consequence of infrastructure failure becomes that much higher, right? And so drought has truly devastated the forests in Northern California and Southern California, again, creating the potential for catastrophic incident like what happened in 2017. So in 2017, PG&E's power line sparked nearly 20 catastrophic wildfires, mostly in wine country. so at least 22 people were killed. There's the potential that it may have started another fire that killed an additional 22 people. That's been a bit of a subject of dispute. But the point is that, I mean, the devastation was just abject. The photo says it all, right? And so most of these fires started, again, because trees came into contact with the company's power lines. And so in the immediate aftermath, the company goes into a very sort of reactive mode of trying to do more to keep vegetation away from the wires. And the very next year, you have the campfire starts for completely different reasons, which is that a power line that really hadn't been closely looked at in a number of decades failed for fairly simple reasons, like the simple reason we're talking about in the beginning, which is that hook holding up a high voltage wire broke nearly cleanly in half. It had never been replaced. I mean, the actual cost of replacing the material would have been very little. I mean, one of the reasons why the line had never really been subject to super close inspection because it's in a very remote area. I mean, it would have been difficult, but the cost of that inaction is far less than the cost of what happened. And so between the 2017 and the 2018 fires, the company incurred an estimated $30 billion in liability costs. More than 100 people died, thousands of homes were destroyed, businesses, and it ultimately led to a second bankruptcy filing, which is really truly remarkable because bankruptcy is really uncommon in the utility industry since these companies are almost all but guaranteed the ability to make money. But so the restructuring process was really complicated for the company. It ultimately came out without an investment grade credit rating. Its share price has been very, very slow to recover. And the victims of the fires were ultimately compensated through a trust that was funded half with cash and half with shares in the company itself. And that was not only just sort of an indignity for the victims, many felt, but also it was just a really grueling reimbursement process because, again, the share price was very slow to rebound. And the trust only just recently sold its last block of shares to be able to compensate these victims many years after the fires occurred. And so it's the company now is very intent on trying to reduce the risk of its equipment starting more fires. One of the ways that it does that is when conditions are risky, often around this time of year in the fall, when you have very strong offshore wind patterns in California, the company will proactively turn off the power. And it presents a really difficult sort of proposition, certainly for customers living in those areas, right? And it becomes more complicated as we talk about other means of emissions reduction, right? Electrifying your home, becoming fully reliant on electricity for cooking and home heating, and just simply opening your garage to get out the EV or charging the EV. And so the safety has sort of, the safety improvements have come at the expense of reliability. And that's something that I think the company is trying to do more to make it so that it won't have to sort of rely on these types of measures, but it's going to be a really long time before it's no longer has to do that. And one of the ways that the company is trying to address this is by putting the power lines underground. PG&E and other utility companies for a long time have said that undergrounding, as it's called, is prohibitively expensive, but it now says it is the most cost-effective means of reducing fire risk because an underground power line really can't start a fire. The risk is next to zero. But right now it costs about $3 million a mile. And the company is trying to do 10,000 miles of this. And costs in California for power, and certainly for other things, are already very high, right? So there's a lot of tension at the regulatory level as to how much of this should be permitted in the interest of sort of long-term safety versus the upfront cost of that investment. And one thing I want to make very clear is that this is not just a California story. Other utility companies in the West are grappling with very serious fire risk. Pacific Core in Oregon is facing a great deal of liability costs tied to a series of fires in 2020. What happened in Hawaii was just, I mean, it was horrific, and that company is also grappling with a great deal of potential liability costs and settlement costs that it recently arrived at. But even just when you're thinking about the context of the West and drought, it's just part of the picture. Utilities across the country are coming to understand that sort of their historic ways of doing things is not adequate as climate change presents new stress in the system. And already in so many parts of the country, the grid is really very old. So a lot of money needs to be invested to simply maintain it. A lot of money needs to be invested to upgrade it, to support our overall carbon reduction targets, whether that be at the generation level or sort of at the distributed household level. And even more needs to be done to assess new risks and be able to safeguard against sort of the new stress that may come as the climate continues to change. And so I think that more utilities are becoming aware of this. The smartest ones are trying to do more to really do a top to bottom assessment as to what this could mean as it relates to sea level rise, temperature changes, certainly drought as we've talked about, storm intensity and frequency. And the challenge though, and is that, I mean, there have been signs of this for a very long time. And as time goes on, it becomes more challenging and it becomes more expensive to address. And ultimately, these are problems that we are all going to have to deal with because we are all utility ratepayers. But also the consequence of infrastructure failure is becoming a lot higher. And so I look forward to taking questions on the panel later. Thank you.
That was excellent. Thank you, Katherine. We're going to take a break. So how long is our break? Okay, thanks, everybody. It's a good problem to have people find a space and sit down, because it means that you're all talking to each other, which is 95% of the goal today, really. Okay, so we're going to move to the next two speakers. And to introduce our next speaker, I'm going to bring up our area lead in climate adaptation and mitigation and the social sciences piece. So that's Kevon Rhiney.
Thanks, Julie. My name is Kevon Rhiney, and as Julie mentioned, I'm the area lead for climate change, mitigation, adaptation, and resilience with the Rutgers Climate and Energy Institute. And I have the pleasure of introducing our next speaker, Julia Watson, who will be joining us remotely. She wasn't feeling well, and so we're very happy that she's still able to participate and share her insights and work with us. Julia will be presenting on Lo-TEK infrastructures of an ancestral future. And I kind of see this kind of connection with Katherine's talk, right? Because what became kind of clear in Katherine's talk was that the dominant ways or traditional ways as we know it of doing things are becoming less and less effective under a changing climate. And in some ways, what Julia's talk will kind of highlight is that maybe the kind of solutions or the innovations that we should be looking into aren't necessarily things that are out there or things that we don't know. They might actually exist, and by kind of thinking about indigenous practices that have in some ways been neglected or overlooked, and in some cases even erased, those traditional knowledges and ecological practices might actually have the seeds for really thinking about alternative futures. So I'm really kind of excited to be presenting or introducing this speaker, because of course it speaks to some of my own work in the Caribbean and Central America, where I work a lot with smallholder farmers, and I kind of really do work looking at their traditional practices and really try to think about ways in which we can integrate scientific knowledge with traditional and local knowledge and practices. So Julia Watson is an Australian-born author, researcher, lecturer, and landscape designer based in New York City. Watson is an expert on nature-based indigenous technologies and focuses her work at the intersection of anthropology, ecology, and innovation. Her eponymously named design consultancy foregrounds traditional knowledge, sustainability, and nature-based solutions. Her award-winning book, Lo-TEK, and TEK standing for Traditional Ecological Knowledge, designed by Radical Indigenism, highlight tech case studies from mountain landscapes, forests, deserts, and wetlands, and has been featured in the New York Times, The Guardian, Vogue, and the Washington Post. So I think, and I'm assuming from the title of her talk, that she'll be kind of sharing some of her own insights from the book and from ongoing work that she's been doing in her studio and in her consultancy. So with no further ado, allow me to please invite Julia to make her presentation.
Thanks, Kevon. As you can tell, I'm a little bit under the weather at the moment. I'm going to try and make my way through this presentation without coughing, but I think that might be 99% chance I will cough in terms of probabilities. But I'd like to start today with a land acknowledgement. I'm sitting here today in my studio in Brooklyn, and you're sitting as well, listening from the first lands of the Lenape, of the original inhabitants, the Lenape people, past and present. And I want everyone just to think about and acknowledge that we're able to hold space and speak about these really incredibly important issues on these lands and on both the land and the Lenape. I hope you can all hear me. So I'm going to begin with a passage from my upcoming book that was spoken by the Gunadule people of Panama and Colombia, and they live on a series of islands. This is one of them that you can see in the background, and a coastal strip of land. And they're poised to become some of the America's first climate change refugees. These are their words. I just want to acknowledge and be clear, these are not my words, these are their words. In the cosmovision of some indigenous peoples, the sea is a mother's amniotic fluid. So when something affects the sea, it also affects the mother's womb. And despite all the damage that has been done to it, the sea still continues to produce food with much love. So that we can say energy is love, because everything we have on earth, placenta, oil, coal, is pure love. Because they are bodies of Mother Earth, and we indigenous people have taken advantage of this, but we do it in a harmonious way. So today I'm going to be presenting work from both my previous book and my forthcoming book called Lo-TEK Water. It's a sequel to the first book. And I published this first book in 2019. It was at the start of the pandemic, and it was at a time when my publisher said to me, and I quote, "This is the worst time you could ever publish a book for a first-time author." So with these exceedingly low expectations, I watched as this book, which was really a labor of love, became a perennial bestseller for a publishing house that was really known for more entertainment type of publications. And they even had to coin a new genre for this book. I'm going to introduce you to the word Lo-TEK, L-O-T-E-K, and explain it because I made it up. So Lo-TEK is derived from local and traditional ecological knowledge, or TEK. And the book, which is Lo-TEK, designed by radical indigenism, as Kevon had mentioned, it's really a provocation towards the biases held against local peoples, traditional peoples, and indigenous peoples, and their so-called primitive technologies. And until Lo-TEK, terms of communication, all of these technologies have been classified as LOW-TECH. And if you look that up, that the definition of low-tech is unsophisticated and primitive, when we're actually talking about incredibly sophisticated technologies that embody many of today's sustainability principles, which include low embodied energy, low impact, low cost, and would have are incredible contributors to the bioeconomy. Low-tech even goes beyond sustainable. It doesn't just form closed loop systems. It harnesses the energy of nature and ecosystem cascade, and it creates continuous flows that are exponentially generative. So these systems really, once managed and constructed with human help, they begin to just run themselves in a way. In Lo-TEK, in the book, the really sort of high-level thesis was I questioned the dominant mythology of technology that threatens our planet. And then I examined what our definition of technology actually is, and just postulated whether some of our most sustainable technologies are already rooted in the traditions of people who've been adapting to climate extremes for millennia. And the book presented us an alternative to either conquering nature in the name of progress or saving nature in the name of conservation by showcasing where communities not only survive but thrive by designing nature-based systems. And so with some of the most imminent threats to communities arising from water, the sequel documents ancestral aquatic technologies. And this sequel is bookended by case studies and contemporary design projects. And it's sort of Lo-TEK is this second exploration that identifies where design has been infused with TEK, and not only talk to these ancestral case study technologies as case studies, but draws from, and this is the really big difference, identifies restoration projects, material technologies, landscape architecture, flood mitigation strategies, buildings, architecture that have never been spoken about in the context of traditional ecological knowledge, but definitely use design methodologies based upon TEK to mitigate some really big climate shocks and stressors, even in urban environments. So I think also, though, the real reason I wanted to write a book about water was because one of my most vivid memories from my childhood was sitting glued to the television, the only form of communication back then, watching the Exxon Valdez oil spill. And so I'm sure many people in this room remember that as well. It happened early on a spring morning in 1989 when a super tanker was sailing through Alaska's Prince William Sound, and it ran aground and it spilled 10 million gallons of crude oil. And the reason I remember this is because days as a kid, I watched news reports of oil slick birds, and obviously I loved little ducks. But I saw them dying and being the ones that were rescued being washed in household detergent, and the numbers kept on coming out. There were 300,000 seabirds that were killed, 3,500 otters, 300 harbor seals, 250 bald eagles, and 22 killer whales. And while me as a kid sitting at home watching the TV was listening to all these animals' lives that were being lost and tallied, there was not really a mention of those who were most profoundly affected by this spill, the communities who'd occupied this territory and were dependent upon, for their livelihood, upon these animals for thousands of years. And people like locals like Chief Walter Meganak of Port Graham's Anunga fishing village, he spoke really differently. He didn't tally animal deaths. He spoke of the water itself dying. He said, oil in the water, lots of oil killing lots of water. Never in the millennium of our tradition have we thought it possible for the water to die. But it's true. And I think that's really significant that in the thousands and thousands and thousands of years that this community had lived in this place and practiced and understood their ecosystems through observation, they had never seen anything like this. So during this lecture, I'm going to tell you a story in 5 parts, and it follows the 5 Lo-TEK specifications that speak to the globally observed patterns of local nature-based innovations, and they are living, co-evolutionary, co-energetic, symbiotic, and cyclical. We inhabit a planet that is living, and it is in the throes of responding to the rapidly warming atmosphere and waters, and logically, we need to design cities of living and responsive materials, systems, and infrastructures as part of a whole gamut of solutions. However, our specifications and codes present real challenges, as in my profession as a designer, to using regenerative ancestral design, and they direct us to design with dead, static, and toxic, rateable, and insurable materials and to create infrastructures rather than incentivizing us to design with living, dynamic, healthy, and renewable materials. And so in this new book, so to begin to bridge the gap between the dead and the living, the static and the dynamic, and the disposable and the renewable, the nature-based solutions that I present and the ancestral wisdom, I all categorize them into the frameworks of climate change development literature and policy frameworks like the FAO Food Water Energy Nexus, the IPCC adaptation pathways, and the World Bank nature-based solutions categories, functions, and benefits, just to bridge that gap for policy. So number 1, they're living. For their entire material life cycles, ancestral technologies are composed of complex, responsive, and emergent patterns of interactions between organisms and their environments. In other words, they are living. And so one thing, and there's definitely different worldviews between Indigenous worldviews and the dominant global worldview of technology. One thing that Western science and Indigenous storytellers agree on is that water is where life began. And over eons of earthly rotations, the water in our oceans was the medium that bore life. And this life was energy. And in this water, energy and knowledge about energy was shared between all these entities, and it forged connections to exchange resources and transfer that energy in this emergent symphony of survival. And then over billions of years, these connections built complexity, becoming these interrelated networks of knowledge. And it's these systems of interrelated networks of knowledge and energy that local people came to understand. And rather than classifying this knowledge into silos of isolated expertise, which Western knowledge systems tend to do, Indigenous knowledge systems use relational understandings of time, place, and the web of players, and that sets it apart from Western science. And so I'm not going to define what Indigenous knowledge systems are. I'm going to rely on incredible Indigenous author, professor at Deakin University in Australia, artist and weapon maker, Tyson Younger Porter. And he explains Indigenous knowledge systems as a big, vast network of knowledge and people inquiring and exchanging what they've seen over quite a big period of time and distance. You have these networks of verification and falsification, systems of knowledge, peer review processes. Sounds pretty familiar, doesn't it, in an academic atmosphere, similar to what we do in academia. So Lo-TEK are co-evolutionary. These vast networks meant that ancestral technologies survived and evolved alongside successive multiples of generations using limited resources and adapting continually to their environmental conditions. I'm going to take you through 2 examples here in the Americas. So in the Pacific Northwest, the Swinomish Indian tribal community are constructing an intertidal infrastructure which is being used to protect against intensifying weather and tidal events. It's a 200-meter wall, and it forms the base of a seaside terrace, and it is the first modern clam garden in the United States. And what it's doing is it's providing a place for clams to inhabit, but it's also increasing biodiversity, and it's mitigating climate challenges through technology that this community have deployed for 4,000 years. They are growing their own climate mitigating infrastructures. And then on the opposite coast, on the Atlantic Ocean, there is a 6-generation women's collective that is leveraging a 13,000-year-old relationship with the sea and seaweed for ecosystem remediation, forming the first Indigenous-run kelp farm on the East Coast. And they are doing this because there are shocking amounts of pollution, and kelp is an incredibly fast, I think one of the fastest growing living organisms on the planet, bio-uptaker, and it's assisting with the ecological remediation of the waters in Shinnecock Bay. So together, these two examples show that while ancestral infrastructures might be abandoned, or most likely they're outlawed, kinship collectives across the globe are reviving agriculture and mariculture technologies to grow ancestral climate solutions to tackle new and complex conditions. Lo-TEK are co-energetic. So given we actually live on an energy-saturated planet, ancestral infrastructures are opportunistic, being activated by sustainable and non-exploitive passive processes and dynamic flows. I'm going to take you through 4 examples of these co-energetic systems found around the globe. So from ancestral movements that energize the tides and systems like the Rhiney agricultural sand islands of the Amasya in Tunisia, which support lush gardens in a hostile, salty, sandy lagoon environment, to the solar rays that siphon wild salt in the Michigan salt pans of the Goans, that then these pans of clay creating microtopographies in which they capture water, then evaporate into salt, transform during the monsoon into these sponge-like marshes where they support all different types of biodiversity, and they absorb the floodwater that can potentially threaten the communities that inhabit behind these systems, to the metabolics of material decay that support the buoyancy of the bioagricultural islands at the top and bottom of this image. These are long strips, 1.5 to 1 meter wide, constructed floating islands up to 100 meters long. And they're made from invasive water hyacinth by the landless people of Bangladesh, to those 1,000-year-old microbes in the water cleansing machine that surrounds the raised bed agricultural beds, the raised agricultural beds of the Chinampa of the Nahuazoquimilca in Mexico. These are quite well known system, and they're known for growing food. But what they're not known is they're actually an incredible wastewater cleanser that are cleansing about 60 to 70% of the water coming out of Mexico City through this wetland system and through these microbial systems that exist there for thousands of years. And they've supported civilizations for a really long time, like the former Aztec Empire. These indigenous infrastructures are still found across the globe, forming the foundations of local climate resilience. But universally, in architecture, landscape architecture, urbanism, engineering schools, and I'm sure far broader beyond in a lot of different disciplines across the planet. In my research, I have found that ancestral infrastructures are deliberately being excluded from curricula, and by doing that, they remain removed from the collective imaginings of communities who are designing and analyzing and predicting what our future could be. And this is leading to their erasure. And it's landing us in places like this, sprawling cities around the globe. And this city was once built on a lake. This is Mexico City. And this lake is now, this city is now suffering from exceedingly fast subsidence. It's going into the ground, it's subsiding, sinking, and incredible water shortages from some of its infrastructure, but a lot of it's also climate. These technologies get commissioned by urban sprawl, colonial infrastructures, or even worse, by very well-meaning landscape architects and designers who are coming into these spaces and designing climate resilient mitigation and adaptation solutions. So the solve for this global issue is, I think, the institutionalization of Indigenous knowledge systems and nature-based technologies. And this is going to have a profound effect in many, many ways, but especially in shaping the imaginings of the next generations of world's dreamers, shapers, scientists, and leaders. And then across the globe, this institutionalization is slowly starting. And last year, to support that, I co-launched the Lo-TEK Living Earth curriculum and digital database. And in it, we use Lo-TEK, the book, as a launching point to examine the mythology of technology and 10 nature-based technologies. And it's housed in something that I started this year called the Lo-TEK Institute. And through this curriculum, what we're doing is creating a global curriculum so that scholars all over the world are learning from their ancestors and the knowledge that's been passed down through generations. And it's through this type of endeavor that I also am calling on others, people like yourself, to help build awareness, and to also join in the institutionalization of Indigenous knowledge systems to build universal climate literacy that includes the dismissed voices and histories of our nature-based technologies. So Lo-TEK are symbiotic, and they create conditions for interspecies exchanges, and they rely on those relationships to function. So I'm going to take you now through a project that I did designing hybrid Lo-TEK infrastructures for the year 2040. And it was a project that was exhibited at the Barbican Museum in London in the year 2022. And high level, it's a playbook for how designers and scientists can collaborate with Indigenous communities to co-create hybrid climate resilient technologies that are infused with traditional ecological knowledge. So the project brief that was given to me as an artist was to design a Lo-TEK future for the year 2040. So first thing I did was I invited 3 communities, the Subak in Bali, the Madan in Iraq, and the Warkasi in India. And then I invited an engineering firm, Bureau Happold, to co-create 3 ancestral futuristic Lo-TEK infrastructures that we displayed as projection mappings over 1:500 scale models. And what we were actually showing, this is an image of the model, but then we projected over that the impact of the performance in that environment of the 2040 infrastructures that we designed. So with the Subak community, what was born was the 2040 water sharing and cleansing infrastructure. With the Madan community, we co-created the bio-buoyant infrastructure. And then with the Wakasi of Northeast India, we infused the intelligence of the living root bridges to conceive of a 2040 living canopy. So I don't have time to take you through all 3 of the communities and their infrastructures, but they're incredible. They're Indigenous knowledge systems and ancestral technologies. Yeah, trust me, they're gorgeous and incredible. They are highly sophisticated, but I am going to take you through one, and that is the living root bridges. And so the Wakasi live in a forest that receives more rainfall than any other place on Earth. And so to deal with that, they have a hilly topography. They have a monsoon rain that rushes through this landscape and submerges it. They designed and grew for the last 1,500 years living bridges. Here you can see 2 of those. There's an upper deck and a lower deck living root bridge. And they did that by leveraging a phenomenon called inosculation. And that occurs when 2 individual trees are growing in very close proximity, and essentially they become one organism. And so to grow a living root bridge, a father will plant a pair of Ficus elastica trees on either side of a river, and it will be his son's son who will actually benefit from his work. A bamboo scaffolding is constructed. The secondary root systems of the Ficus elastica tree, once they begin to grow down, are woven through this bamboo scaffolding. Once those roots from one tree reach the other side of the river, they are then planted into the ground of the opposing bank, taking root, and then the roots actually grow into a bridge. And at the moment, in this landscape, there's over 70 of these structures. So the living canopy was proposed to grow symbiotically with the expansion of urban walkways across a sustainable urban transportation network. And it was specifically designed to target Indian cities where temperatures regularly soar above 40 degrees Celsius during the day for most of the year. The canopy is designed to reduce urban heat island effect. It's designed to create a microclimate that's comfortable for pedestrians. It's supporting urban biodiversity. It's reducing pollution. It's sequestering carbon. It's doing a lot of good things. Then there was a fourth technology that came out of this whole process, which I'm going to show you as a transcript. It's a legal technical innovation to ensure that the Indigenous intellectual property that was captured through the consultation process actually remains with the traditional owners. It was exhibited as a sound shower. So you listened to it. It's a 9-part oral contract that strips away a memorandum of understanding to its very bare legal essence. It's called the Smart Oath of Understanding. It's a legally binding commitment that bridges the gap really between Western and Indigenous approaches to agreement making. So in the exhibition, the CEO of Bureau Happold spoke the first 8 parts of the SOOU, then the 3 communities responded in their own dialects, and I ended with an English translation. And this process now protects the Indigenous intellectual property for those communities involved, and they remain the owners of the knowledge that they have shared. So the smart part of the SOOU's name is taken from the term smart contract, which is a contract that's stored on a public blockchain. And so it's transparently encoded, can be automatically triggered. Compensation in the form of cryptocurrency can be distributed to an organization that sits within the community and is controlled by the communities, uses provenance tracing technologies to assign ownership of that technology to that community in that place. So this SOOU, which was 2 years ago now, its second generation is going to play on loop as a soundscape in the first Lo-TEK case study house, which is commissioned for the upcoming real estate exhibition at K21 Dusseldorf in Germany in the winter of 25-26. So we are creating a pavilion working with an architect, Katherine Larson, who has this project called Seaweed Thatch Reimagined that's featured in the next book, and Dutch master seagrass thatcher, Laura Feline Hebison. She is the first female thatcher that's educated in over a decade. We are bringing Katherine and we're bringing Laura to the museum to construct what we're calling the House of Understanding, or thus. And in it, we will preserve the knowledge and the craft of seagrass construction from seabed to structure, and providing a roadmap for working with local bio-based resources to integrate traditional materials back into contemporary architecture, while ensuring Indigenous intellectual property is protected through real-world, oath-based, smart contracting technology that works alongside contracting agreements. This particular thatching technology that Laura is going to share with us has never been documented. It's from the island of Lasau and Molsk, located now in what we know as Denmark. And it is a many thousand-year-old tradition of using materials from the sea to construct housing that you find all over the world with communities. So Lo-TEK are cyclical. They are triggered by the repetition of the sun rising and setting, days, seasons, years, birth, life, and death, in opposition to the irreversible linear construct of time as past, present, future. This is really important. I won't be able to come back to it, but I want something like this to sit with people. I'm going to start to wrap up here, but I'm going to show you the way these new technologies, contemporary technologies are hybrid technologies are presented in the forthcoming book. So the transition towards a deeper understanding of our planetary systems is, as we know, in the past week going to be fraught with failures and with frictions, but the process of shaping the infrastructures of an ancestral future, it's already begun. So Lo-TEK Water, as I mentioned, dedicates the second half of the book to these recent material technologies, huge landscape projects, restoration initiatives are infused with TEK. Here you see an example of a fire retardant, thermally insulating architectural system that's being developed for emergency housing, that's being co-evolved with the Lake Titicaca communities. And it's using their traditional mat weaving technologies. And the Lake Titicaca communities live on floating islands on the border between Peru and Bolivia. And so these types of bioclimatic, cost-effective, biodegradable, and regeneratively sourced material technologies, when spoken about in the context of traditional knowledge, really speak to the fact that we can evolve technologies that are part of our bioeconomy, that are deeply embedded in local tradition and offer pragmatic resources to very urgent climate-related problems. Lo-TEK is not authored by a single person. It is created by innumerable voices that have listened to nature, and they have transcribed millions of conversations that have taken place over thousands of generations. And these conversations, they still form the foundation of earthen architecture that has shaped shelters for thousands of years. Projects like Emerging Objects from Roded Real and Virginia San Fratello are pushing the boundaries of earthen form using enormous armatures to create previously impossible tectonics by 3D printing them. Some of these TEK-infused projects are known globally as the most preeminent flood-resilient projects around the world, like Thammasat University Rooftop Farm by Kochvakaram in Thailand, which draws from thousands of years of terraced agriculture to transform slopes into productive ponds, while pioneering innovative stormwater and waste management systems. And Kongjan New Sponge City, this is probably one of the most well-known types of projects around the world. Sponge cities bring traditional cut and fill boulder dike technology from local farmers to reshape intertidal terrains and create closed-loop systems around fish rearing and food cultivation. It is in these projects that the blueprints of good ancestors are being drawn. Though people are drowning in this age of information while starving for wisdom, they can still tune in to knowledge systems of local communities that give voice to seemingly silent waters while replacing the outdated frameworks that consider the earth and all she offers us as extractable and expendable. And if any technology is needed in this climate crisis, it is the ancestral nature-based technologies that have co-evolved with communities across the globe for tens of thousands of years. And custodianship prevailed before the mythology of technology that made humans the Earth's greatest threat. But relations of 7 generations before us have already given us the lessons for life to endure. Thank you.
Thank you, Julia. I hope you stay online and get a little tea and rest your voice, and will join us for the panel in just a few minutes. So I'd like to invite up Atif Akin, who will be he is our area lead in terms of climate communication and environmental humanities, and he'll introduce our last speaker.
Hi, good morning, everyone. My name is Atif Akin. I'm an artist and designer, and I'm a professor of design at the Mason Gross School of the Arts at the Rutgers University. And it's my honor and pleasure to introduce another Rutgers University professor, Dr. William Hallman. Dr. William Hallman is a distinguished professor in the Department of Human Ecology at Rutgers University, an experimental psychologist with expertise in public perceptions of risk and risk communication. The goal of his research to help people better understand and respond to risks to human health and to the environment by making informed ethical decisions as individuals, citizens, and policymakers. His work over the past 35 years has focused on numerous issues concerning health, food technology, and the environment directly connected to the climate change, including food safety and the food insecurity, foodborne illness outbreaks, infectious diseases, air quality, coastal storm warmings, and many other topics. Dr. Hallman is an elected fellow of the American Association for the Advancement of Science. an elected fellow of the Society of Risk Analysis, and a distinguished research fellow at the Annenberg Public Policy Center of the University of Pennsylvania. He is currently a member of the National Academy of Science, Engineering and Medicine, Climate Crossroads Advisory Committee, the successor to the Climate Communications Initiative, which he co-chaired. So please join welcoming Dr. Hallman.
Thanks so much to the organizers for inviting me to give a talk. To those of you who have known me for quite some time, see, I really do own a suit. And to my students, see, I really do own ties that are older than you are. So I'm going to talk today about communicating about climate change, and specifically communicating to facilitate understanding emotions and actions. And the most difficult task I had in preparing this talk is deciding what not to say to you. And that is sort of the problem with all the communications related to climate. So what I hope to accomplish is to perhaps remind you of some things that you already know and can put into play, maybe tell you some new things and maybe surprise you just a little bit. So let's go. So in trying to be an effective communicator about climate change or anything else, you really kind of need to start with figuring out what it is that you want to accomplish. Are you here to educate people? Are you trying to help people understand what's going on with climate change, what the consequences are, what the options are, what's effective, what's not, so that people can make their own decisions? With education, you're providing information so that people can decide for themselves. Duh. What I want to point out is that that is a very different enterprise than trying to persuade people, where you're persuading people to try to, to change their beliefs, their attitudes, or their behaviors, to kind of get on board, to do something new, or for God's sake, to stop doing some of the old things that they've been doing to improve climate. Education is not the same thing as persuasion. But there's a third thing that I want to emphasize, which is we don't just educate, we don't just provide information to let people make up their own minds, we don't just provide information to try to persuade people to do something. We also need to engage in dialogue and partnerships for decision making, where we are engaging with stakeholders to try to understand their needs, their concerns, their starting points, and to discuss information that will essentially lead to better collective decision making. I do a lot of consulting work, I do a lot of advising to international bodies, I do a lot of training of regulators around the world, and one of the most difficult things I have to train scientists to do is to shut the hell up and listen. How many of you have had a course in risk communication or science communication in your graduate lives? More than I would have expected. That's great, that's wonderful. All of you need to raise your hands, okay? It's more than just understanding the science, it's understanding how to explain it or to interact with normal human beings where they are. What I want to point out is that the assumed roles of each of these different goals, education, persuasion, and having a dialogue with stakeholders, differs in terms of key assumptions with respect to who has information, values, or viewpoints worth sharing. With education and persuasion, you as the communicator, you know everything, and what you're doing is, bestowing your wisdom upon your audience. And that's not always appreciated. Let me just say that. So it also differs in terms of who should be part of the process of deciding what should be done. And one of the things that I try to train regulators to do and policymakers is, if you're going to claim that you're going to have a discussion, don't walk in already knowing what it is that you're going to do and then try to defend what it is you've already decided to do in the guise of a discussion. I've seen that. My dissertation was in South Carolina looking at environmental conflicts, and I saw this over and over and over again, and I got to the point where I knew when to look for the exits. because people would get up and they would say, let's discuss this. And it was clear they've already made up their minds. All they're trying to do is defend the decision they've already made. So conflict, and I mean real conflict, physical conflict, I've witnessed this, occurs when these assumptions are not mutually shared. So figure out what it is you're trying to achieve and make it clear to your audiences what it is you're trying to achieve. And in fact, I want to sort of emphasize again, you know this, explaining the facts is not the same thing as persuasion. And for many of us who are scientists, this is kind of what we do. We explain the facts in our papers, and we expect those who read it to sort of follow along with the assumptions and the methods and the conclusions, and you are persuaded by my new findings. But even those of us who are scientists don't do that in the rest of our lives, right? We're not necessarily persuaded simply by understanding the facts. If I was persuaded by simply understanding the facts, I would be 50 pounds lighter than I am. I'm on the nutritional sciences faculty. It's not that I don't know the facts, it's just that there are pastries in the back of the room. So explaining the facts is not the same thing as persuasion. And the key thing from psychology is, if your intent is to persuade, say so. I'm going to try to persuade you today that climate change is an important thing that you need to pay attention to. But you need to go beyond that and say, I'm going to try to persuade you because this impacts you. So one of the hoaxes, one of the ideas, one of the things we need to get beyond is that there are people who are benefiting from this idea of climate change. And here's a tweet from the next commander-in-chief. The concept of global warming was created by and for the Chinese in order to make US manufacturing non-competitive. So if you have that starting point, my trying to convince you that you need to take action may be interpreted as, well, you're just helping the Chinese and trying to sink manufacturing. So explain why you're trying to persuade people. To whose benefit is it? And make sure it's to their benefit, not necessarily to yours. Maybe you wouldn't be surprised, the people in the room, as to what people think the motivations are for explaining climate. So as a psychologist, I want to talk a bit about the drivers of beliefs, attitudes, intentions, and behaviors. There are really two things that you need to keep in mind. There is cognition, so understanding the way that we think about the mechanics of climate change, its consequences, the social context that surround this, so who's in charge, who benefits, and so forth. Potential actions and their effectiveness, so how we think about these things. And then there is affect or emotion. There's fear and anger and anxiety and frustration, mistrust, helplessness, resignation, protectiveness, and so many others. Cognition and affect drive beliefs, attitudes, intentions, and behaviors, not cognition alone. And one of the questions that often comes up is, which comes first? Cognition or affect. And I will tell you that many of my colleagues in psychology, and particularly in economics, believe that cognition comes first. First we think, and then we feel. And I'd like to point out that those people have clearly never been in love. Because if you thought, okay, you kind of get this idea. Often we feel first. We kind of cut to the chase. We don't think carefully. We use heuristics and we feel, and then we try to explain why we feel or justify after the fact the action that we took. So sometimes emotions come first and then and then cognition, and the affect, our feeling then provides a filter through which we see all of the facts, right? More about that in a minute. I would like to point out that a lot of the climate change education that we engage in is fundamentally about cognition, connected to mechanisms, connected to facts. This is a very complex set of things to explain to normal human beings who have other things on their minds. And the mechanics may not be that important to them. There is a National Science Foundation Science Indicators report that comes out every couple of years where Americans swear that they're really interested and supportive of science. What they actually mean is they like the results of science, all right? More than 80% of Americans say that they're in love with science. 80% of Americans do not watch NOVA on PBS, right? So we know that there's a bit of social desirability bias in that answer. So, they're not necessarily interested in all the details, they're interested in the big picture and the results of this. Advocates' messages often rely on affect, on emotion, often connected to consequences. So here's an example: polar bears at risk of starvation as Arctic ice sheets melt, scientists warn. So they're trying to grab you emotionally to provide a filter through which you're now going to see all of the other evidence that they're going to provide. And activists also often rely on affect connected to values to try to, to force you to take action, to point out that we agree on certain kinds of values. There is no planet B. We need to take some action. Now, again, I can't tell you everything that I want to tell you in a half an hour. Hopefully, I'll leave my address at the end and we can have a conversation at the end. What I can do is to try to kind of highlight some of the key mistakes in communications related to climate. First, again, to remind you, explaining the facts is important. I am not saying that we need to stop explaining the facts. We need to keep explaining the facts, but we need to address both cognition and affect if we're going to try to persuade and motivate. The tendency of scientists, this is why I asked how many of you have had a course in science communication. The tendency, when I was in grad school, I had no course in science communication. I was taught that science is objective. There is no emotion in science. There are only facts, and you just need to explain the facts and people will understand. That may work in certain settings. It may work at our disciplinary conferences, but it does not work at Thanksgiving, okay? So we can't simply expect the facts to be persuasive on their own. We, in fact, need to use both cognition and emotion when we talk with people, particularly if what we're trying to do is persuade them to act or to stop acting in a maladaptive way. So how can you do that? Well, there's lots of work out there, stories, photographs, videos, metaphors, analogies that highlight the threat, that illustrate the consequences, that personalize those who are or will be affected, enables the audiences to see themselves in the story, to be empathetic with those who are affected or will be affected, and to see themselves as potentially affected, or at least one with those particular communities, and that connect with shared values. We are much more effective in beginning with an exploration of shared values than trying to explain the data, okay? Numbers are numbing, as many point out. Key mistake related to emotions: failing to recognize and acknowledge the emotions of those that we're speaking with or are speaking to us. Many people, this is quite well known, experience what's referred to as climate anxiety. And I have this in quotation marks because this is not part of the DSM-5 that I'm aware of. And what I want to point out is that climate anxiety is real. Man, I've seen more tears in the last week, not just related to climate, but it's a lot what's going on. I think we need to acknowledge that. And so some of that anxiety is in fact adaptive and motivating. We need to act now. I'm anxious, I need to do something about this. But climate anxiety is not universally adaptive. It can be maladaptive and debilitating for people who don't know what to do, who don't know to act, don't know how to act. And we need to sort of understand who we're talking to and where they are on this scale. I will also point out and remind you that climate anxiety, at least some of it, is exacerbated by framing climate change and its consequences as a crisis, a looming disaster, or an inevitable catastrophe, without also pairing this message, which is designed to motivate people to take action, without pairing it with ways to take action to relieve that anxiety. So all warnings simply raises emotional reactions without giving an outlet for that. And that can generate kind of a learned helplessness and a hopelessness among people. So we need to be careful about the unintended consequences of the way that we frame climate and its consequences with the good intention of trying to get people to act. It doesn't work the same way for everybody, so let's be careful about that. Another mistake related to emotions is viewing emotional responses to climate change as fundamentally pathological, okay? Some anxiety, some depression, some emotional reaction is directly related to personal experiences. If you've been through a flood, if you've been through a hurricane, some of these are directly related to personal experiences, destruction of property, loss of life or health, the financial difficulties that many people now face because they can't afford insurance and they can't move. These are real, and the emotional reactions to that are real. So some are caused also by realistic warnings of climate-related threats. Even if you've not experienced it personally, you've seen it on the news, and you live in an area where the projections are that their sea level rise is going to be a problem, if you're not a little bit anxious, as a psychologist, you should probably come and see me. So let's talk a bit about cognition. And your mantra for today is mental models matter. Mental models matter, mental models matter. So what do I mean by mental models? Well, it's the big picture, the way people see all of this working. And I argue here, it's important to understand what people think they know, whether what they know is accurate or not. So let's understand what people think they know, so their starting points. It's more important, though, I would argue, when we begin to communicate, to understand what people want to know. Because you're much more likely to get people to stay around for a long talk if you begin with answering their questions and then segue into the things you think they need to know. And in order, of course, to understand what people want to know, you have to have a conversation with them, at least with your projected audiences. So it's important to understand what people think they know. It's important to understand what they want to know. More important to understand how they think about it. So how they put the facts together, how they think all of this works, and again, who's involved. It's more than just the mechanics, it's the social context of this. How do they put it all together? What is the big picture, and how do they construct that for themselves? What are their influences? Mental models matter, mental models matter, mental models matter. We can't know everything. I will point out that only about 1/3 of Americans have a college degree at age 25. Fewer than 10% of Americans have a college degree in anything related to science. So people's starting points in terms of the principles are perhaps not as high as we would like in trying to explain more complex issues. So we often have incomplete mental models of how things work or why, but we need to navigate life without knowing everything. We do this every day by filling in our mental models with available information and sadly misinformation that is plausible, fits with what we think we already know or believe, fits with our identities. So, we have kind of an existing mental model, and we build on that using bits of information from Twitter, from advertisements, from wherever. As long as it seems to fit, that's good. And so what are the keys to plausibility? It offers a simple explanation for a complex phenomenon. Some of the most attractive conspiracy theories provide an explanation. Oh, well, that's why they're doing that. It's wrong, but it kind of makes sense. Provides a mechanism or an association that you already think exists, or connects analogously or metaphorically to a mechanism or a relationship you already believe exists. So it doesn't necessarily have to provide a scientific explanation. It just can be a metaphor that kind of works for you. Then we get into confirmation bias. This phenomenon goes by a bunch of different names depending on the discipline. I prefer motivated reasoning. And essentially what this is once we've decided something, we look for information that's consistent with what we already believe, or what we've already done as a way to justify why we were right in the first place. We reject information that's inconsistent with our beliefs. We twist information that's inconsistent in ways that make it consistent with what we already believe, or we dismiss it as the exception to the rule. And then finally, of course, we tend to reject the information or resent the people providing it who are trying to correct us, right? So, we're looking for the snowballs to bring to the floors of the House of Representatives, all right? Sadly, this kind of sums it up. We would prefer to believe a reassuring lie than an inconvenient truth, because believing an inconvenient truth means we have to act. There's also social pressures to conform, social norms. I love this. If you've not experienced the mommy mafia, if you've never had kids, it's real. I live just outside of Princeton, and Muffy only goes with a lunchbox full of organic food. And I can't believe that you sent your son with a peanut butter and jelly sandwich. Just what is wrong with you? You can't be in our club anymore. And speaking of clubs, there is identity politics as well. I love this. This was on the Walmart website. This Trump 2024, the Return Drill Baby Drill t-shirt is perfect for any casual occasion. Good for work, depends on where you work, I think. Daily, office, travel, and homeware. So get yours now. Motivated reasoning in social media amplifies this. Why? We kind of, again, remind you, the kinds of things that you see on social media are not random. They are mediated by algorithms which are targeting you for specific information based on your demographics, your previous searches, the things that you've shared, the things that you've liked. It's not a random sample of news. Social media also filters news through our friends, highlighting views and opinions with which we are typically already going to agree because we're with our friends. And what happens if you disagree with people, on social media? What happens if you disagree? They're not your friends anymore, right? So you're weeding them out. I had to weed a couple out this past week, actually. And most of us are connected to a very small number of like-minded users. We are not Beyonce, we don't have millions of followers, and so we have kind of sort of a tight-knit group of people who are telling us things we're likely to agree with, creating a kind of an echo chamber. So where are we in terms of beliefs related to climate change? This is from NORC in, I think, April of this past year, so pre-election. The good news is the majority of the public actually believes in climate change. They just don't believe that it's human-caused necessarily. And so two things about this. One is the roughly 80% who don't believe in climate change, good luck trying to change their minds for all the reasons we just said. And you may not want to spend your effort there. Trying to convince your grumpy uncle at Thanksgiving that climate change is real is probably not where you want to spend your efforts. We also are in this for the long game. So part of what you want to try to do is to get to people before they've made up their minds. That means getting to younger people and providing a kind of inoculation so that by the time they become grumpy uncles, their minds are kind of made up in the right direction. So the challenge here is getting people to act regardless of their belief in human-caused climate change. And in changing behavior, we know that in order to change your behavior, you have to be convinced that you or someone that you value is vulnerable, that the consequences of the threat are worth avoiding, that you know what to do and when, that you've got the skills and the equipment and other resources necessary to do what you think you need to do. And that if you act, your efforts are going to be effective and meaningful, and moreover, that what you're doing is also being done by other people, that you're not the only one who's doing this, creating these kinds of new social norms. We need a mommy mafia around climate change. So again, understanding kind of what your goal is. What are we trying to achieve? Well, what are the logical interventions? What needs to change to be effective? The technologies, the policies, and so forth, and at what level? At the individual level, at the corporate level, at the international level? And then fundamentally, if you're having conversations with people, what do they need to do as individuals to make these changes happen? And there are some clear barriers to effective individual actions. We've all encountered them. Here's one, again, this is NORC data. Who is seen as responsible for doing something about climate change, to act? Individuals are seen as bearing the least responsibility. It's somebody else. It's corporations, it's the federal government, it's developing countries, developed countries. It's not me, it's you who are the problem, right? And there are lots of justifications for inaction. There's commons thinking. We're familiar with the commons problem. You know, others have much larger impacts, so they should do something first, then I'll act. If everyone isn't making changes, why should I be the only one? Why should I be a loser and a sucker and take action against climate if not everyone else is doing it, and there are costs to doing so? The road to hell is paved with good intentions. You know, I'm waiting for the technology to get better. I'm waiting until there are better incentives. I'll do it when I change my roof or my water heater, then I'll do it. I promise. One of the other issues that we face that I think we need to be realistic about is that many of the things that we're asking individuals to do is framed as a sacrifice. And I'm not sure how well this actually shows up on the screen, but this is separated into low impact, moderate impact, and high impact. And the highest impact here, is have one fewer child. I've already got 3 children. I love them all. Which one has to go is a really difficult decision. So that's not necessarily a practical solution. You know, giving up your car. I work at Rutgers. The public transportation between Princeton and Rutgers, you know, is not all that great, so that's probably impractical, and so on. And what we end up often doing then is we don't want to make big sacrifices. That doesn't work for us. And so we do a lot of the low impact things on the list and then try to think, okay, well, I'm doing my part to fight climate change. So I'm what's called sufficing. So what are you doing to save the planet? For many people, it was taking my private jet to COP28 in Dubai, because after all, I can justify the private jet trip because I'm changing the planet, I'm saving the planet, right? And you know, we don't all have private jets. I'm not the football coach here. But many, you know, at a more local level, you know, taking my F-150 to go buy Impossible Burgers, you know, aren't I a great person when my F-150 Raptor gets 12 miles per gallon, right? So I'm doing my part. I can justify my actions. There's also a belief that a technological solution will save us. And we often see these things in the news. They make great news, but if this is going to save me, why would I spend the money and the time to try to take individual action to do my part? That would be ridiculous. Like many things, there's also a lack of feedback loops. People can't connect their individual actions with tangible reductions in climate consequences. Again, you probably can't see this all that well. These are top options for reducing your carbon footprint. At the top, live car free, and it will reduce 2.04 average reductions per person per year in tons of CO2 equivalent. Is that a lot? How would I know from this chart? What is my overall contribution? Would this be cutting my contribution by half, by 10%? You know, I don't really know. Improved cooking equipment, have no idea what that means, but this is the BBC, and so, you know, it must be important. This is from my PSE&G account, my account dashboard. You can see here that I'm using a bit more electric this month compared to a year ago, but less gas than a year ago. Am I winning? Is that good? Do these trade off? Like, where am I on this? So providing feedback loops that are intuitive to people, we can do a much better job of this. And as psychologists, we can probably help you with that. We also need to encourage effective individual actions. We need to use terms that better convey intuitive meaning. We need to stop trying to force the scientific terms onto normal human beings. We need to choose terms that actually capture the gist of what it is we're trying to get across. There's an interesting story in Scientific American last February. The right words are crucial to solving climate change. Marketers know this. Marketers know that what you call something, what you name something, then creates a frame through which everything else is filtered. Is it climate change or is it climate disruption? Is it greenhouse gases or is it disrupt, or is it pollutants that are warming the climate, warming the planet? We can also try to influence social norms. One of the things that we know is that when one person puts up solar panels in their neighborhood, it then creates a kind of snowball effect. So one of the things that we need to do is to provide incentives and provide the people who do this with the ability to explain why to their neighbors. We also need to market the other benefits of climate interventions. So this is from Her Money. So this is a targeted presentation to a particular demographic. This is the 10 things we can do now to combat climate change and save money. So it's not just about believing that climate change exists, that you're a good person. It is you can save money. Framing targeted to the priorities of specific audiences also makes sense. So here are 3 lists. One is tips to save energy at home. The other is 7 simple things to save money on your electric bill. And the other is 10 life hacks to save money and energy. These are different audiences. People respond to different incentives. We need to be careful about this. And what I want to point out is that many of the actions are the same across the lists. All right? Because if you're saving energy, you're probably saving money on your bill. It's just a question of how you're presenting it. We also need to be clear about the target and the language that we're using. Are we trying to reduce our carbon footprints, be carbon neutral, be net zero? What does that actually mean to normal human beings? I have a brother-in-law who's a net zero. Greenhouse gas negative, what is it that we're trying to get people to understand and get towards? Let's be careful in this. And again, here are 4 different ways to reduce your household carbon footprint, features of a net zero home, carbon neutral at home, and the potential for US agriculture to be greenhouse gas negative. Is that a good thing or a bad thing, to be greenhouse gas negative? We need to choose our terms so that normal human beings understand what we're trying to get across. And then finally, we need to do framing and marketing to unsympathetic audiences. Doing that and marketing these benefits appropriately to coincide with their implicit values or explicit values can help overcome resistance to being identified as believing in climate change as the reason for your action. Here again is our next commander-in-chief, claiming, I'm an environmentalist. I am. I want the cleanest water on the planet. I want the cleanest air anywhere. So trying to convince the next commander-in-chief that climate change is real is probably not a winning battle, but saying we need to reduce carbon emissions to reduce pollution may be something that he could get behind because he doesn't have to admit that climate change is real. Okay, I can hope. Jean, don't shake your head like that. And finally, let's think about unintended consequences. Lots of things I know, lots of things I don't know. One of the things I know is that throwing soup has not cooled the planet significantly. And in fact, it has had the unintended consequence of pissing people off. So here is data, this is in time. Throwing soup at art shifted people's views of climate protests, but maybe not in the right way. So what it did was it actually created a kind of divisive response from people. So let's think about what it is that we're really trying to achieve. So that's what I have to say to you today. If you'd like more information or would like to complain, this is where you can find me. And I will do a commercial. Next semester, the Department of Human Ecology has a certificate in human dimensions of environmental change. I am teaching a seminar on risk and science communication. So you can sign up for that and we can have a much longer conversation. Thank you so much.
I'd like to invite our panelists to come up and have a seat, and we'll entertain some questions. So you might want to grab something to drink, the panelists. Is Julia still on? I don't know. Yes?
I am.
Can you put her on? Or Oliver? How did we get Julia on the thing? Okay. Ben will be right back. Yeah. Okay, so the way I'm going to structure this, because we're all getting hungry and I'm standing between you and lunch, which is never a good place to stand, is to, we'll have some folks in the room who have the microphones that are ready, so you can ask a question. Remember that we let the students go first, so we'll let that happen, but as we sort of pull that together, I'm going to ask the panel a question directly, and Ben will be back in just a minute. And Julia's here too. Thanks, Julia, for staying on. I hope that you got a little cough medicine and something good for your throat.
Yes, I'm trying.
I first want to thank you guys so much. I think that was a fantastic morning of discussing a lot of different interesting ideas. And I also want to thank you guys for being here and participating in this conversation. So all that's fantastic. So every year I sort of come to the end of these things and it's like, all right, I need something helpful and hopeful to hang on to, right? And so I'm going to start actually by asking you, each of you, if you can think of an experience or a moment maybe you've had in your career or even your personal life that you found as inspiring and made you feel like either that your work is making a difference or that it kind of cuts through what feels like a lot of gloom and doom at times, and what's going to happen, where are we going next, where's this future that's going to feel a lot more hopeful in terms of what the climate situation looks like. So I'll open that up to you guys. If anybody wants to be brave and take the first answer on that one, then please go for it.
I guess I'll start. For as challenging as this moment is in a lot of ways, I think often when I come and speak about California burning, there's an assumption that PG&E really hated the book, and that's actually not the case. The company, when it came out, it was under new leadership, and I mean, PG&E is actually my biggest customer. PG&E has bought hundreds of books and distributed them to employees, and sometimes I've had the opportunity to speak with executives and lower level employees who worked through the various disasters and had just shared that different aspects of it were really meaningful to them, and it has helped improve decision making and just having a more holistic view of what happened. And more than that, a lot of other utility companies have are learning from it and trying to figure out what the lessons are for them in their particular territories and geographies. And that's, it's really encouraging, and in my opinion, it's if the work even positively affects one person's decision making, that feels very gratifying. So that's my hopeful bit.
Thank you.
I can go next.
Okay, go for it, Julia.
Earlier this year, I had the opportunity to open up the American Society for Landscape Architects annual meeting, which is a 3-day meeting. And it's really well attended, both internationally and nationally. And so I opened as the first speaker, which really set the tone for the entire conference. And I did that with a friend of mine, who's an Indigenous Diné woman, she's a scientist, and she also is sort of, she has researched these types of large scale, more agricultural traditional food systems. And so we presented that together. We both spoke. She did a song. We did a call to action at the end. And it was really significant because you would think that, landscape architects have constructed a whole ethos around supporting biodiversity, greening the environment, yet we've only just begun to think about creating an ethos around supporting the communities and the knowledge systems that have retained 80% of the biodiversity that we know exists on this earth. And so that was a really significant moment, both as a recognition in the field and to set a mandate that was actually sitting under the society's climate change agenda, which they took to COP. So for me, that was something that was incredibly significant, that finally, after 4 years, there was this huge, not only recognition, but a call to action within the entire industry that hopefully will set a benchmark for other institutions regarding institutionalization of Indigenous knowledge systems.
Well, thank you. Bill?
Oh, so many things. Because I'm well known for my non-cynical demeanor. I think one point of hope. So I serve as an advisor to the National Academy of Sciences, Engineering, and Medicine Climate Crossroads. And one of the reasons that came about is that I co-chaired something called the Climate Communications Initiative, which was a kind of cross-cutting initiative to bring together different units of the National Academy of Sciences to focus on climate. And I remember Marcia McNutt, who's the head of the National Academy of Sciences, having a conversation with her at a cocktail party. And I said to Marcia, of all the things that you could choose, why would you choose climate? It's the most controversial. The National Academy is supposed to be nonpartisan, science-based. And I was like, there's a lot of conflict here. She said, yeah, but we really need to do this, because it's the most important issue of our times, but if we can't do this at the National Academies, what can we do? And so because we were successful with the Climate Communications Initiative, it became the Climate Crossroads. And I'm proud to be an advisor of that and continuing to provide a social science perspective. The second thing is this issue of a social science perspective is being more and more valued. More of my science colleagues are asking my social science colleagues to be, part of the party here. We can't do it alone. We can't do it with science alone. We have to understand how people think and behave to persuade them to do things that make sense. So I'm encouraged by that. I think we've got a lot to do. See you in 4 years.
Go ahead. Ben, do you have a microphone? You're in. Okay. Go for it.
It's tough if you wake up one morning and arguably the most powerful person on the planet says that everything that you and your colleagues have done over your entire careers is a hoax and a conspiracy, uses that kind of language. That's bad. On the other hand, it also produces opportunities. That's the word that comes to mind. Like it or not, climate science has been elevated in public discourse, and it gives all of us in this room, faculty, students, the opportunity to speak publicly about scientific understanding, about consequences if we get the science wrong. I didn't have those opportunities 30 years ago. I do now. And the challenge is to make the best use of those opportunities to speak science to power through the kind of initiatives that Bill talked about, through the work that Julia and Katherine are doing. They're extraordinary opportunities to use our voices. I would also say that something that makes me optimistic is those 12 words: the balance of evidence suggests a discernible human influence on global climate. What I learned nearly 30 years ago now, in November 2025, it'll be 30 years since that finding, is that words can change the world. And when you're told you're powerless as an individual nothing you can do or say can really change things. No, that's wrong.
Julie, I'll say one
Yeah.
more thing, if I can have my mic. I also believe that there are teachable moments in the disasters to come. One of the things that we know from the data is that all of a sudden, people who have lived through a climate-related disaster are more likely to believe in climate change. There are opportunities to talk about, in the wake of these disasters, what the reality actually is. And as dreadful as the flooding and the hurricanes were, it's woken up a lot of people who, we didn't get a chance to talk about all of this, but their solution to the climate crisis is to personally adapt and go to a climate refuge, or at least where they thought was a climate refuge, and now they understand maybe they can't escape it. So there are teachable moments that are coming up. We need to seize those opportunities and maybe have some B-roll ready to show on the video.
So I'm going to build on that, and then we'll move to questions. And that's, you guys have already spoken to the fact that we are likely facing a lot of challenges moving forward with the recent elections and other really kind of global political factors. And so, and maybe you've already answered this to some extent, but where are those moments to communicate? Where are those moments to influence what's happening next? What does that look like for you in terms of your work or your experiences? Easy question.
I'll start. So one of the things that we laid out in the Climate Communications Initiative is that there need to be many voices that have control over different levers. And when we started the initiative 5, 6, 7 years ago, one of the things we pointed out is that private companies, mortgage companies, insurance companies, play a big role in who gets to live where, and what risks they can realistically take. Now, it's turned out that a lot of people can't get insurance, they can't move, and they're really stuck. But there are opportunities to work with private companies, for example, to amplify the good work that they're doing. There are lots of people who do believe in climate change, regardless of who's at the top, who may be willing to support particular policies or investments in particular companies that are following policies that fit with their priorities. So, we're probably not going to see a lot of positive initiative from the federal government, but there are lots of other actors that we should not ignore.
So in writing for the journal and writing I often get the most reader emails in relation to anything climate related or renewable energy related. Usually people who are skeptical at best about climate change or the economics of renewables or how viable they are in supporting the grid. And, I think 19 out of 20 times those readers don't expect a response. And I try my very best to respond to everyone, unless they're like demonstrably nuts. I will try to take the time. And I think that there's certainly been times in which that's been a really fruitless exercise, but there's been many more in which people responded really positively to having received a response. I think a lot of people maybe don't feel like they can be even a part of this conversation or feel unheard. And so I try to affect some positive change in that way. And I think that, just feeling heard and feeling as though you actually have a line in to someone who can go back and forth with you a bit. I mean, I'm going to keep trying to do that. I think these emails are going to get more frequent going forward. So we'll see.
Yeah, I can go.
Sure.
So, Julia?
Just zooming in digitally above, but Yeah, I already mentioned it. For me, there's another book that's coming out that is sort of now, and I think the books are a really important tool and platform for highlighting a theoretical framework, but also every single chapter, every single piece of work in the book is co-authored with an Indigenous expert. So it's really a space of uplifting voices that may not be heard sort of on a global platform. And then on the other hand, I showed the curriculum, and really that is an opportunity that I think has to really change the foundation of education. It's already been adopted in Canada through the ecological high school certification process of eco schools. And for me, I think I was a professor for 12 years in high level education, had 4 students that came through that were from Indigenous backgrounds and understood that their ancestral knowledge and histories had a place in shaping the future of the world that they live in. And I think that really trying to give a basic literacy, climate literacy for high school students, which initially that curriculum was written for, is a really big way to sort of get rid of the naysayers and the questioners. And it's an attempt to say, well, as in accompaniment to STEM foundation, to STEM education, we must have a basic climate literacy for everybody coming out of high school.
Thank you. Ben?
A couple of words about opportunity. One is, I'm incredibly grateful for this opportunity here. Every one of these talks is like a stone thrown in the pond. When you throw a stone in the pond, you generate this complex pattern of ripples. They reflect, they interact. You have no idea what kind of complexity you generated through the simple act of throwing that stone in a pond. Every lecture, every public speech is like that too. You have no idea who's in the audience and what they may do or not do based on the information you've given them. Sometimes it's incredibly gratifying decades later to meet someone who says, hey, I listened to that lecture you gave about fingerprinting and I decided I was going to be a climate scientist. So for all the students in the room here, there's so much for you to do out there to work on the solution side of things, to work on improving our understanding of likely outcomes. That makes me optimistic, those kind of opportunities to throw stones in the pond. And man, I want to keep on throwing stones as long as I possibly can.
Excellent. So let's invite some folks to ask questions. I know Judy does, but I want to make sure there's some students who, if you're a student, raise your hand up. If you could introduce yourself too, that would be great.
So is this working? Okay. I'm Ryan Hobson. I'm a meteorology student here at Rutgers. And my question is for Mr. Santer on the end. So in your presentation, you talked a lot about like the trends and the signals in terms of temperature in the atmosphere, but could you maybe go into a little more detail about like some satellite data you've seen in the past or some future model runs in terms of water vapor and the trends you've observed with that?
Thank you very much for that question. I'll try and be brief. I want my other colleagues here to have plenty of opportunity to speak, but a quick story. So with the satellite temperature data, initially there was only one group in the world trying to use that information to make statements about global scale changes in atmospheric temperature. And they initially concluded that the atmosphere, the lower atmosphere, was cooling in complete contradiction to surface thermometer measurements of warming of the Earth's surface. It turned out that that group was wrong. They had made serious errors in looking at their satellite measurements of temperature of the lower atmosphere. And one of the things that was powerful in showing that they were wrong was by looking at water vapor. So water vapor is completely independently monitored by different sensors on different satellites, and water vapor was increasing in the lower atmosphere. A warmer atmosphere holds more moisture. So it was that ability to look at what people in my world call complementary variables. Hey, if temperature is increasing, but water vapor is decreasing, or if you say it's cooling and water vapor is increasing, something's wrong there. And that's the power of looking at many, many different aspects of climate change. So I didn't show this today, but we did fingerprinting with water vapor that showed that water vapor is increasing. The atmosphere is moistening. For about every 1 degree Celsius warming, you get a 7% increase in moisture in the tropics. And that's bad news for all of us, as we see with Helene and Milton and storms that are feeling this warmer, moister atmosphere. So it's incredibly powerful to take off blinkers, to not look at temperature changes only, but look at many different observable aspects of climate change.
Thank you. Yes.
Taigüey taum mautia, wow.
Our way of saying, good day, good sun to you all. My name is Wasawa. I'm a student here at Rutgers in the plant biology department. And I wanted to ask a question about notions of changing behavior and the effectiveness of efforts, especially considering that some of the data that was shared with us today suggests that individual responsibility is well in the 20s sometimes. And really my understanding is a questioning for how we can create the notion of what we were sharing about an appropriate ethos to retain biodiversity that is synergistic with the resurgence of indigenous technical knowledge systems, or as our speaker was sharing about Lo-TEK, and the reestablishment of stewardship practice, not ownership practice, of land. And I'd like to introduce the example of the Saliha in Yellowstone and the return of, sorry.
Hi, yes, so that's kind of why. But for everybody who's online, I just shared Taigüey taum mautia, Diri Wasawara, just sharing with you in the way that we speak in our homelands in the Caribbean, that I'm looking to see and understand at a greater level these notions of changing behavior and effectiveness of efforts in light of the individualistic responsibilities being really low in the data sets that were shared today, but really asking how we can create an ethos to retain biodiversity that is synergistic with Lo-TEK, indigenous technical knowledge systems, and a return of stewardship practices similar to what has happened in areas of my homeland like Ile Avanche and Boca del Cachon. Some areas of Boriquen now are experiencing it, and the environment, the communities are not responding to it in a collective way, a communitarian way. But what we see in national models like the Saliha, like the Salish and the Kootenai in Yellowstone is that when stewardship returns to people who have an association with the land, the bison return, the biodiversity returns, the medicinal plants return, the landscape literally evolves. And so are there any ways, mechanisms, or methodologies that you guys could recommend for indigenous peoples, communities, to bridge that synergism between the ethos, the pathos, and the presence in science and rigor? Thank you.
Thank you.
Yeah, thank you. I was just going to respond to say at the federal level, I was on a panel a few weeks ago with the person who was underneath the Secretary of State, and there is a huge agenda that I'm not sure about the longevity of this agenda under the change of administration, but for putting federally reserved land back into co-management with Indigenous stewards at non sort of profit levels, at sort of smaller levels. There is another nonprofit that was previously responsible for the Drawdown book that has transitioned now. Their primary agenda is now to support 25 Indigenous leaders from around the world to make them responsible for areas of forest that are in protection, and to bring forest stewardship back under those Indigenous owners of those territories. So those are two strategies that I know are in place. I missed a little bit of what was spoken earlier, but I think somebody else had a contribution as well.
Couldn't you ask an easy question? It's all right. I think it's an opportunity to again point out that different messages for different audiences are going to matter. Marketers know this. One of the mistakes that we make is trying to deliver sort of the same information to different audiences with different starting points, expecting the same outcome. And that's not what happens. So finding audiences who have a toehold kind of in this space, who may be open to hearing more, is where you need to start to create a kind of social norm that this needs to spread. Trying to convince my grumpy uncle at Thanksgiving that this is the way we need to go, the gravy's just going to curdle. It's not going to go anywhere. So I think being realistic and finding the stakeholders who share those values and pushing them to the next step is where to go, not trying to convince the right-wingers that this is for them, because good luck. And you may get what's called reactance. You may get a pushback that's kind of worse than if you hadn't tried to convince them in the first place.
Thank you for that question. Yeah.
Hi there. My name is Samantha Niven. I'm part of the Blaustein School, getting a master's in city and regional planning. But my area of focus is environmental justice. And Ms. Blunt, your book reminded me a lot. I grew up in Seattle, and I remember during the summer having to stay inside and not being able to go outside because the air quality was bad, because the wildfire smoke does travel that far. But I think about the intersectionality. Your numbers were all about deaths, but I was, as a child growing up with asthma, knowing that there were vulnerable populations that were so deeply affected. Intersectionality is what I focus on a lot in my work. And so I think my question for all of you is, especially, how do you communicate that intersectionality without the kind of doomsday mentality, but also that celebration of indigeneity and the ways in which we can use ancestral knowledge to address intersectional problems as they've been addressed in the past?
Well, thank you for that very thoughtful question. And I think that try to answer it the best I can. It's been very important to me as a journalist to examine there's a great number when you think about sort of vulnerable communities, vulnerable populations. I mean, there's a lot of different ways to explore that, and specifically in the context of California, a lot of people who have been most affected by fire and fire threat are people who have sort of had to move out of like the Bay Area and places that are very expensive into the Sierra foothills, where the cost of living is lower, but the risk is a lot higher. And so there's like conversations now in the wake of fires as to like, first of all, there's the issue of getting insurance, right? There's questions of like, should you be allowed to rebuild? That is a very, very difficult, fraught, and controversial question that is beginning to come up more often. But even in terms of like what we were talking about earlier, proactively turning off the power during times of high risk, that's an inconvenience at best, right? There are a lot of people who rely on electricity for medical reasons, and asking people to go without electricity for possibly days is a very serious economic question as well. And so I think, I mean, it's just, I will continue to just try to do my best to like help people become aware of the issues that this poses for people at the individual level, at the community level, and just in the hope of like thinking and talking critically about the trade-offs that we're asking people to make here as we deal with these very real climate consequences of our own collective creation, right?
I was going to say I speak and write with a woman who her name is, I mentioned her before, Dr. Lila June Johnston, and she communicates very well how Indigenous knowledge systems and science can work together. She calls it the hardware and the software, and the hardware are the types of technologies that you can show and the data that can come out of analyzing the impact of those technologies, like the heat mappings and the performances that we showed in the Barbican exhibition, and as a projection mapping. But she also talks about the software, and the software is the value systems that surround this knowledge. And she speaks about that, when in the Swinomish community, by creating the terrace that they were creating, they're not just creating it for environmental mitigation or for providing a space for clams, for a food source as a traditional food system, nor is it just for boosting biodiversity. The reason they are creating that particular infrastructure is primarily because there's a shared respect for clam nations and a respect for other forms of life, and that clams actually have their own nationhood and a value system that places humans on the same plane as other forms of life. And those value systems, coupled with the science or the technology, are incredibly valuable, and something that really needs to be communicated. And working with the IFCCC, that's actually what a lot of the work that is happening in those spaces at the United Nations is, looking to Indigenous communities around the world to share knowledge, to establish some sort of value system that the UNFCCC can share with the rest of the world, that can start to form an ethos around climate adaptation that is not just about the technology, because the technology can't compete with the economics, but around changing values of humans and human nature. They're still having a lot of trouble with that. There's also a really interesting that she speaks to in terms of the values, that this knowledge was given to the communities, and the communities are sharing that knowledge with the rest of the world. And a lot of people have trouble with the fact that some of this knowledge is being shared by a lot of Indigenous leaders in related to climate change because of a risk of appropriation. Her response to that has always been that these systems, some of them have been around for 4,000 years, some of them a few hundred years, but the intention of these systems was always that they would be reciprocal, that they would be used in a very specific way to support all forms of life, that they were not just economically driven, and that they were not to be put in place to be exploitative. And that is the intention by which you will have success, by creating the types of systems, contemporary systems. And if one is to create these types of systems with the idea that it would be economically viable and it would be extractivist, it's going to fail. It's not going to last more than 10 years. And so there is a primary value and an understanding in the creation of these types of, using these types of Indigenous knowledge systems and models for climate solutions, that we must think broader, we must think intergenerationally, and we must think longer. So the values as well as the technology is incredibly important in understanding how do we adapt to climate change.
Thank you. So I'm going to open it up to any other questions. So Judy?
Thank you. I'm Judith Weiss. I'm not a student, although I still am learning. I'm a retired professor from Newark. I'm a biological scientist, an environmental biologist. And it's occurred to me through this meeting that throughout my career, I have always sort of prioritized the courses that I taught for bio majors and for my graduate students that became marine biologists. But now I'm rethinking that. I taught for many years a course for non-majors called Environmental Issues. And I think perhaps the years of teaching that course may have had more overall impact on the world than the marine biologists that I produced. That's not a question, that's just a statement. I have a terminology issue with Professor Hallman. The terminology that I hope you will not use anymore is believe in climate change. I mean, a belief is a religion. You believe in seances, you believe in a religion, you believe in astrology. Climate change is like mitosis. I don't believe in mitosis, I understand it. I don't believe in photosynthesis. So I'm asking you, would you please not refer to climate change as a belief?
And next, we have to say the same thing to the New York Times and other journalism sources.
So I think it's a point well taken, and I was using the terminology that was used in the survey. And you're right, this is essentially the way we talk about it. Do you believe that it's human caused? It is human caused, it does exist. The question is, are you on board with that? Is that part of your mental model? But since people don't understand that mental models matter, you can't ask normal human beings using that terminology. You have to see where they are and ask them where they are. So I think it's a well point to take.
Any other questions?
Yeah. Is this on? Oh, okay. Hi. I actually am writing my dissertation on misinformation in climate industry, so I want to respond to the idea that it's not a belief. We are in a situation where, in New Jersey, the biggest correlation to whether you are pro or anti-wind energy is your political party. Republicans overwhelmingly do not believe that not only do not believe that wind energy is a viable solution, but do not believe in climate change. I think that Kellyanne Conway was prescient in 2016 when she presented alternative facts. We are in a world now where alternative facts are accepted as fact. So the idea that climate change is like mitosis only matters to us. It doesn't matter to the people who don't believe in climate change. And by the way, it doesn't matter whether they believe in mitosis or not. This is a clearly held belief and fact to them. I have been at congressional hearings. I was at one where literally every time somebody said climate change, the guy behind me said, "Oh, climate change." And I, for the first time in my life, felt physically threatened that somehow I was not going to get out of this, unscathed. I do think we have to look at people where we're at, where they're at, but I also think we are entering a political time in our lives that is going to upend everything that we know and what we do about climate change, and we need to be prepared for that. I think, by the way, not only climate change is an anxiety, climate anxiety is real, it's studied by communication scientists, but right now I'm in the, unbelievable climate anxiety because I don't know what's gonna happen next month. And I think that we as scientists, I'm a social scientist, I think we have to kind of understand anybody here who's working on wind energy in New Jersey, be prepared to have your funding cut in 2 years. That's all it will take. The incentives for wind energy are going to change. I mean, the good news is that when I talk to the wind energy companies, they see this as a long game, and they see this as going to take 25, 30 years. And therefore, if they miss out for a year or two, they have the finances to ride it out. But it will be anxiety-inducing for everybody else.
Just quickly add that I think it is so important to try to speak to people where they are. I mean, if we have any hope of reaching anybody, I think that is really important, and it's a really tough question that I have to ask myself and think about. I mean, who am I really reaching, right? I mean, how do we speak to people who quote unquote don't believe, right? And whatever sort of that means. And I think there's often nuance associated with that as well. It's maybe that they understand that there's something legitimate about climate change, but they're upset about some of the proposed solutions, right? Or, and like, yesterday there was the gentleman who was driving me in from the airport I was telling him a little bit about why I was in town, and he was like, well, I think I already know the answer to this, but what do you think about climate change, right? And I was like, well, just the framing of that, right? I have an idea of where he stands. And so it was just, I'd said, the science is unequivocal, period. I said, but the challenge of confronting it is very complicated. Which aspect of it do you want to talk about, And so, so anyway, that I appreciate your remarks, Sarah, and just, trying to talk to people where they are is really the challenge of our time, I think.
Ben?
Maybe I can say a few words about this. I've tried very hard after the discernible human influence finding to speak to a variety of different audiences, not just my peers, but highly conservative organizations like Bohemian Grove, sometimes called Summer Camp for Billionaires in the middle of the California redwoods, including people like the Koch brothers and many titans of industry, all men. And for 45 minutes, they had to listen to the same information I gave you today. They might not have liked it, but the hope is that in speaking to different audiences, you give them pause for thought. What are the consequences for you and everything you hold dear, your kids, your grandkids, of being on the wrong side of the science on this one? And that's the best you can hope to do with some of these audiences. Get them to think about what they care about and what it means to be on the wrong side of history and on the wrong side of science. And again, I want those kind of opportunities because I firmly believe that if you receive government funding, as I did for 30 years, it's like a social contract. You have a responsibility to explain in plain English what you did with the money. What did you learn? What did you and your colleagues do? And why did what you learn matter to other people? And irrespective of the color of the political administration, as scientists, we've got to continue to do that. To the very, very best of our ability.
Bill?
I could not agree more. And I think it's important to kind of follow through, understanding who your audiences are and their starting points, and explaining the science, great, but if we don't come to some conclusion or provide some advice at the end of explaining the science, and we simply expect the billionaires in the room to figure out for themselves what this means to them, we're only halfway there. And having heard your talk, Ben, I'm sure that you explain to them this is what it could mean to you, but we're not typically trained as scientists to do that. When we talk to journalists, for example, we often sort of lay out the facts and expect the journalists to draw the right conclusion. Well, no, you need to draw the conclusion and make it clear and put it in plain English. This is what this means. So we need to do a much better job at that.
Okay, I think with that, I'm going to stop and we can continue this conversation over lunch. Now, we have to be orderly about lunch. So I was told. So we have to kind of do it. I was going to say it feels like church, and I need the people to come down the aisle and say that it's your time to go to the front. But we'll start kind of with the front here and move away back, and then kind of go row by row as a line up. So that's the easiest way. We're sort of blessed with a nice full house, and we have plenty of lunch, but we have to be, You told me to start with the front row, Marjorie. Oh, all right. Then we'll go to the back row, and they'll go first, and then then we'll go from there. So before we do that, I want to thank all our speakers today. Thank you so much. I want to especially thank the folks who flew in, and I want to thank Julia for joining us, even though she clearly is not feeling well. So take care of yourself, and I hope things go well. And enjoy lunch and enjoy talking with each other.